So good morning, everyone. Well, for most of you this morning, not for everyone, as we learned yesterday. Thank you for joining on this second day around Payara Micro and Cloud Native Microservices. Yesterday was a bit more basic, architecture things, basic things like CDI and JAVAPRO, which are of course very important. They are the building blocks of your application. Today there will be more, a bit more advanced topics. Also a bit more to that microservice cloud native side of the application of all the concepts. But first, maybe I can quickly show the agenda, then you see it. So yes, a bit more about microservices, about MicroProfile, data access, and then integration testing. Any questions that you have around what you have seen yesterday, what we have discussed yesterday? Okay, that's good. Everything is clear then. We continue with something which I did not explain yesterday because either we did not have the time or people said, well, we are not going to spend our evening programming the hands-on exercise, which is fine, but you can play it afterwards. I'm now going to highlight a few things which are important for some aspects what I'm going to tell you today. So I need to switch then to the entire desktop. So the at the first hands-on one in that labs directory here on that GitHub, I can put again the URL in the chat for those that I think I also put it there yesterday. So in any case, you have it now. There are the day one was the Jakarta one. And there was a basic one and a more advanced one for because you always have some different experience with Jakarta EE already in a group like this. And yeah, the basic one is where you have where you need to create some endpoints for a web shop where you can get a list of products, possibly filtered by price and category, where you can add and remove a product for a user. You only have a single user, so you cannot define or create users in this basic example. And you also have some business rules that apply, like you can only have maximum 2 bikes and 1 car and 1 truck. The main idea there was that you learn how to create those JAVAPRO resources, that you are using the different HTTP methods, get, post, delete, etc., and a few validation at the JAVAPRO level and the business level, how you could do that optimally. It's here in the command txt file, so there is how you start a Payara, okay, but then you have all the curl commands, or you can use the URLs if you are using another tool like Postman. And they should work, they should give you something, or if they should not work, you see like here it should fail with status 400, then that's indicated. So based on this, you could have created something that was more or less what I had in mind around this first example. the more advanced one, there is the addition that you add authentication, and basically the same code snippet that we saw in the security of the XRS with the filter, the container request filter, with the basic authentication. And that you have two different payment options also, so that you need to use that instance, so that you need to have the filtering because you have multiple CDI beans that matches there. These you don't need to start from scratch if you want to do it yourself. For instance, if you look at the XRS classes, for instance, this one is, I think, you have just already the class. The idea is that you create all the XRS specific things. So the structure is there. I think even that there is the storage, that there is the initialization of the database, yes, with all the products. So you have all those things available to get quickly started. And in the solution, as I mentioned, for those that heard it yesterday, in the solution branch, you have a working version, which I'm now going to discuss a few items. One of the things which I did not mention yesterday explicitly in the XRS one, it's not in the service, it's in the resource, is that if you have multiple query parameters, so you can, for instance, specify multiple products. I'm buying multiple products at the same time, so you have a URL with multiple times product ID equals B01 from the bike and etc. Then you can use here a list. So the system here, it is delete, but it's also with the post. The system automatically converts those multiple instances to a list of strings. So you get then the list of the products easily here. That's one thing. Yep.
Question on that. So if product ID is not at all in the query parameter, does that make product IDs an empty list or null?
My guess it would be an empty list.
Okay.
Simply because I hope that the system follows best practices and that you should never have null for a list or a collection, but then you have an empty. So I would say empty, but to be 100% sure, you have to try it out. Because yeah, it's a good thing I did not try it out today to remember what it was exactly.
One question that I had was when we are passing the product IDs as query params, do we send it as a comma separated in a single query param, like product ID equals 1, 2, 3, or is it like product ID equals 1 and product ID equals 2 and product ID equals 3?
Yeah, it is exactly as multiple query parameters with the same name.
Ah, okay, gotcha.
If you specify only one product on only one query parameter and you separate them by commas, then you just get a string. Okay. And then you are responsible for splitting that string in a list.
Okay, but this is more sensible then, because it will automatically make it into an array list or list, right?
Yes.
Okay.
You can ask also for all query parameters, and then you get each of them individually. But yeah, most of the time, you know that that's based on your client. What again, it is a client server. It is a combination. So if you know that your client is possibly sending multiple times that query parameter because it has been implemented like that, then yeah, then that list is of course very easy. So that's one thing that's quite useful here, that list. Yeah, that authentication, as I mentioned, it is identical or most, maybe a few small things that are the difference is that container request filter that we saw with an authentication and that is basic, etc., etc. So that's there. There is no validation at all for username and password. It is just if there is username and a password, then it is fine and it is accepted and a security context is created. Yeah, then we have that several payments. We have that we have a payment service, how you're going to pay, and you can pay by card or by invoice. And as you know, I now have then two CDI beans. I have here one application scoped bean representing the card, and I have another one which is then the invoice. So how can I distinguish them? Because I'm returning a certain type. The interface says a method that says I'm the bean for invoice or I'm the bean for the card. And if we are going to look in the user service, I guess it is here. Yes, we inject an instance. So we inject multiple, possibly multiple ones. And then I can do it like this, of course. And then I can just select the correct CDI bean based on the type. So I can just loop over that field, which returns me all those CDI beans, and I select the correct one based on what the user has specified through that URL. That's one easy way. You don't need to have qualifiers in this way because I'm trying to make my life always as simple, as easy as possible. Then this is already for, yeah, more or less, I think it's just after the break, the long break that we have, that we will talk about MicroStream and the database. Yeah, those demo-like things, you create them just within in-memory database. So you have a Pojo where you have a list of products, users, and the products that each user has assigned to it. This afternoon, we will see then with MicroStream that actually, maybe this is a valid solution also for production, that this is your database. You don't need an external storage, MySQL, Postgres, NoSQL, whatever. You don't need it. Maybe this is enough. But more on that this afternoon. So that was the review. Yeah, we discussed a lot yesterday, which is fine. Again, if you have questions today, there were already questions, which is good. But again, if you have questions today, I think it makes more sense that we discuss a few topics here on the session itself, and that you can play around with the example, the hands-on exercise that I created whenever you have time for it and that you want to learn more. I think that makes perfectly sense. This afternoon, if we have time, we can have a small update on that application to include MicroStream there. But if not, again, you have that solution and then you can see how it works. Then a few words on microservices, again, a bit on architecture. So microservices, they focus on a single business domain. Is it about the product, keeping the name and all the data of a product? Is it about a user? Is it about the orders, etc.? So each service focus on a single business domain. And so it has nothing to do with size. Microservices should not be as small as possible, but should be focused on that single business domain, and probably even better to merge a few smaller business domains together in one larger microservice than actually splitting them up. Because was it yesterday or the day before, there was someone that said, yeah, I was again shocked at a company where they said, oh, we are having about 100 or 110 microservices. Oh, fine. With how many developers are you? 20. It does not make sense to create as much microservices as possible. You have that term, that pizza team size for a microservice. So a microservice should be worked on by 4 to 5 people. So if you're having 100 microservices, that means you are working in a very large company because you have 500 developers. So the goal is not to split it up as small as possible. The goal is to make it separate from the rest, as you know, that you can upgrade it, etc. But the more you split it up, the more work you have, and the more issues you have to keep those versions up to date and in line. Those microservices are connected through REST, like we saw yesterday. Ideally, that should not be, like I said, RPC, remote procedure calls over HTTP. Try to do it as best as possible in the philosophy of the REST thing. That is not real and not really an issue if you are just using RPC, but yeah, it's the idea that REST is more about data and documents, that you had the state of those documents and those concepts that you send over the wire. Mentioned already that independently upgradable and scalable. You will learn, for those that have done it, probably have encountered already. Others, they certainly will encounter it. That's the most difficult thing of a microservice. It's not about which technology, or is it Java, is it .NET, is it if it's JavaScript, whatever. The problem in all those languages is keep them independently and keep them scalable. For example, I mentioned there a service around an order. Okay, fine. That's the team that manages that microservice. They have a requirement to update the functionality. So yeah, they can do two things, and they can keep the same endpoints. They can keep the same JSON, for instance, which goes over the wire, to keep it compatible with all the other services which are already installed and running. And that's mostly the case. Well, they need to change it because yeah, they have new requirements. They need to implement new features, so they need to make a change to all those endpoints. But if that order service has a changed endpoints, and then the other microservices, the other part of the applications no longer work because they expect still the old one. There are a few things that can be captured automatically with optional fields, etc. But most of the time, just replacing that order service version 1 with version 2 in production will break the entire application down. Nothing works anymore. Then the solution for that can be twofold. One is yeah, every other team needs to update all the changes also, and everything needs to be installed and updated in production at the same time. But then you are no longer talking about microservices, but what's called by many people a distributed monolith, which is even worse than a monolith, because yeah, you have so many different pieces, and actually they all need to work together and need to be kept in sync and updated and installed together. Other option is that, yeah, you have version 1 which is kept in production for some while, you can say 3 months or 6 months. To the other teams, hey, version 1 is still there, but it will be taken down from production in 3 months, and here is version 2, so please update your code, and then every team can do that independently. And of course, you have multiple versions. Your microservice and your data storage needs to be capable of handling those old and new data in a mixed situation, etc. So this independently upgradable and scalable, believe me, that's the most difficult thing. And then I'm not even talking about what they also say for microservices, mixing different languages, because a microservice, one can be created in Java, the other one in .NET, and the third one in JavaScript. That's also perfectly possible. In theory, it is nice, but again, in practice, that increases the entire complexity. So as people say, don't fight complexity by adding more complexity, but maybe by simplification. I know this is for some people very opinionated and they don't agree with it. So are there any comments on what I said around microservices?
Yeah, I mean, I completely agree with you on the distributed monolith being worse than a monolith. And I per se have been, I mean, I've refactored a lot of microservices back into well-structured monoliths in the last couple of years, especially for smaller businesses when they had to cut down on the team size for whatever reason, you know, and then they realized that the complexity of maintaining like 30 plus microservices, and a lot of them are related from a domain or business perspective. So you could club all of them, at least like a couple of them together into a monolith and deploy it. And so I completely agree on that. One question I had was around the version support and maintaining compatibility. So typically when we like deploy, you know, like we put in V1 or V2 in the URI, you know, and usually this will be front-ended by some sort of an API gateway, which will ensure that the right containers or the right set of servers end up serving V1, and then the other like set of servers end up serving V2 or V3. But if we do not have an API gateway, and I know this could be a very long convo, but I just wanted to briefly get your thoughts on it. If we do not have an API gateway, okay, we just have a very simple, let's say a load balancer in front, and it just is distributing every now and then. So in that scenario, do you think it is sensible to have V1 and V2 in the same application, leaving the V1 code base to serve whatever it was serving, or leave the function intact, and then introduce like another path like V2 and bundle it into the same one? Do you think that is okay from an approach perspective or not really?
I would say yes. Yeah, okay, it does not work, but I just want to show you two URLs. For me, it is, well, you can have this, you can have a JAX REST endpoint, which is explicitly labeled V1 and the other V2, and it returns the order with ID 1, 2, 3 using that V1 or that V2. Then your clients, of course, if you don't have a API gateway or whatever, then they need to explicitly call order/V1. But again, I find that clear. It is clear that the client explicitly uses that V1 version of the other microservice. If they are ready to change, then they can just make the necessary changes on their side and change the URL to V2.
Right, that is exactly how, I mean, I've seen it, because clients could be your mobile apps or a progressive web app bundled as a mobile app or something. And basically they are deployed out there. So, you know, especially line of business apps, it may not be very easy at times to update them. And they might not go through the proper app store or play store because of various reasons. But essentially what happens is that then the path is essentially hard coded at the client level. So, you know, so.
But I also received an app on my Mac last week, and then on a version that said, oh, well, as of end of this month, your application will no longer work because we have changed our backend.
Right.
So then you are forcing the one that has installed that app or whatever. They say, oh yeah, okay, I need to update. Is that good or bad? Well, at least it is clear, and I don't think that a lot of people are bothered that a lot, saying, oh yeah, okay, then I have to update if I still want to use it or whatever. I don't see that a real problem. It's in my opinion. And and it does not force you to use, as you mentioned, other technologies like API gateways and all the configuration that you need to do and the maintenance, etc. And just hard code the version in it, and you can have those version numbering here inside your URL.
Okay, cool, thanks.
Other comments? But yes, it's a good, it's at least, it shows that you need to think about how am I going to handle the future? What if I need to update my endpoints with the new version? Is the way of working that I will introduce, can it cope with those kind of changes? So that's, as I said, probably the most important thing that you need to get fixed and thoroughly thought through how you should do those things. Yeah, that's the classic from the classic image from Martin Fowler. Why microservices have the individual scalable? Because if you scale a monolith, which all the functionality available just once in a runtime, if for some reason that monolith needs to be scaled because the performance is not good enough, you need to scale it in its entirety. You need to probably, you have to add a load balancing, but you didn't. If you have session information, you need to make sure that it gets distributed, etc., etc. So that can be some work, and I agree that probably in several scenarios where, for instance, if you have that orange microservice here, that is basically the one that forces to scale you, well, scaling then everything is not ideal. But as they are all individual ones, which can be scaled individual, but they need to communicate with each other, that's also a very difficult task, a real challenge. So don't take it too lightly. These are mainly two ways to work with those microservices environment. When we mentioned already through that question, most of the time you have a client, but yeah, the client only sees the backend application. Probably it does not even know that there are microservices, and it should not know. So that API gateway here is then there to see, oh, I get a request from the client for that order. So that means that my order service, the red one, for instance, here, gets that request, etc. So that API gateway is also most of the time responsible for enforcing the security requirements. So the service itself, like I did with that container request filter to check, oh, is there a header, etc. If you have solutions like this one with the API gateway, then the API gateway is responsible for that. The code there, you can configure it. You can even create some snippets there in most of the API gateways that make sure that if an incoming request has that it has a certain header value, that it is validated. For instance, the tokens. We come to that later. The tokens, if they are valid, etc. But yeah, here you have then different services. You can have the order, the product, the user, the stock, etc. And then probably they need to call either even remote services, or they need to call each other. Yeah, so you need to know because if you have for the order, it's probably needs to access the stock service to see, oh, is that product available in stock, so that we can say it will be delivered tomorrow, or no, we need to see that we have an order for our supplier ourselves, so that then it takes maybe a week. So that depends, that defines which response I can send. So yeah, the red one needs then to call the blue one, etc. I did not include it here, but it was Netflix, I think, who showed a graphic where you have dots on it representing each microservice, and they have a lot of them. They have several hundred, if not maybe 500 or more, and there were lines and arrows between them to depict the communication. And actually, if you look at the picture, it's just a black screen, because there are so many microservices that have so many interactions with each other that, and they also admitted sometimes a bit, they don't even know what's happening anymore in the system because of all the interactions. And if they need something new, instead of, and that's another solution for the versioning, instead of updating an existing one with a new functionality, they just create a new service. Is that ideal? No, if you ask me, it's not ideal, but okay, it is what it is with the Netflix. So, but be aware that those communications can be very extensive between the microservices, not between four, because you have four, then you only have what, 6 possible combinations or something between them. But of course, if you increase the number, then you have a lot of more communication. Which brings us also to the fact that, yeah, you have that management here that needs to maintain it. Okay, that's fine. But also data needs to be flowing, because, as I said, order service needs to go to the product, to the stock service. And because the stock service has a database, so each service has a database attached to it, containing the data specific for that service. And that order service should not access that database of another service, because, yeah, then it needs also to have the knowledge how it is stored, the logic around that, etc. So all the data is flowing then through all those interconnections between the services. So that's why a lot of people then are forced, because that can also take time to retrieve all the information from all the services, to have also a cache locally in each service for all of the main, the most important data of the other services, so that it does not need to look up there and ask the other stock service, do we have some stock in-house for that product, so that it can look up in its own cache to see if it is available or not, and that you and that information gets updated in some way. That's the right part. I come to that in a moment. That's one solution. Again, another complexity introduces also latency, because yeah, it can be that stock is updated but not immediately reflected. I mean, at the same time, the same millisecond, of course, it's not reflected there. So you can have cases where it is where your data is inconsistent. That can be an issue. That can be fine. That all depends on your use case. So what is then the mechanism to in most what many companies choose for synchronizing all those data and those caching data? It is here shown with an image with AWS Cloud and with lambdas, but it is a general principle. So your service, your product service or whatever, your lambda function as here is called in a synchronous way. And it does what it needs to do based on all the data that it has locally, the data which are stored for the service itself, the product service here itself, or the cached data from the orderings microservice here, for instance. If there is a change on its own data, for instance, there was a truck came into your warehouse and delivered some product, so your stock increased, then there is an asynchronous event that is sent out through an event system like Kafka or any other kind of event system that informs all the other parties, hey, this is the new status of the number of products in our stock. And then all those events are processed by each microservice to update their own database. An additional complexity that you need to implement, the asynchronous call, the asynchronous that you emit those events, etc. Again, microservices are very good in certain occasions. For other, they bring too much complexity and probably not worth all that hassle in many cases. Any comments on this, on these diagrams, what I mentioned about local data storage and event system to distribute data, etc.? And as we discussed yesterday, microservices can be part of your cloud native label that you put on your solution, but cloud native is more than that. It is about automation. So cloud native does not mean that you absolutely need to use microservices to the extent that it is really split up by domain or whatever. You can have groupings, and why not a monolith here? Then you remove that API gateway, you remove that synchronization, you remove that event system for the data, you remove a lot of things So at the beginning, I would strongly suggest that you get familiar with the entire DevOps, automation, CI/CD pipelines, and then if the need arises, then you can start splitting off a certain microservice from that monolith, for example, which is the most expensive one. And then you have a not really monolith anymore, but the monolith minus one service and that microservice that you can scale up 2 or 3 times or whatever the amount is that you need to have a reasonable response rate for the user requests. And then we come to that question, it was yesterday also mentioned, is Java even suited for those large scales, microservices for those cloud, etc. You have those AWS lambdas. Technically, it is possible to use Java for that, but is it also suited? Is it meaning, does it perform well? Is it not too cumbersome or whatever? Because you also know that they say Java is too heavy, is too slow to start up, etc. And all those kind of things. And actually, there are a few people that did some investigation on that. So comparison with Hello World type of thing, but also with a bit more realistic things. When, of course, not full-blown applications, because if you do it 2 or 3 times in different technologies, of course, that takes time. And if you would create, if you would like to create an application 3 times, that takes a year. So that means that you need 3 man-years to finish your experiment, which is very costly. But for those serverless, environments, for example, that's the main area where they say Java is not suited. Just a quick recap, what is serverless? With serverless, your process, for instance, Payara Micro, is not always up and running. In theory, the idea is that serverless means you get the system sees that there is a request for that process, for that function. They call it then a function because the functionality is then most of the time rather small. They start up that process. The functionality is performed by your application, by your function, and the response is returned to the client, and your process goes down again. So it is started and stopped for every user request that comes in. That was the initial idea. Immediately, and it's not even only for Java, they saw, well, it does not make sense to start it up every time. Maybe we can start it up for the first time when there is a first request, and then not shut it down immediately, but keep it warm, as I said. So they keep it active as long as there is sufficient call. So if you say if there is 1 call every second or every half a minute, then okay, that's fine. If that process does not receive anything within the last 5 minutes, then it is taken down because probably it is either not needed due to the low usage in your application, or it's not needed anymore. Period. So that was already one adoption that I did, saying, well, it's useless to start it up every time, even for JavaScript and Node.js and Python and all those things. It does not make sense, of course. That's one thing that you need to know. So they have already made the decision that if you have a function or even an entire application as running on your serverless environment, it is not stopped every time. So it is more or less already like just a normal running application in a container or in the cloud or whatever. But there is another very important factor, especially for AWS Lambdas, is that the CPU is related to the amount of memory that you select. So if you say my process needs 64 megabytes of memory, you get like 1/5 of a virtual CPU. If you say I'm assigning it 512 megabytes of memory, you pay a little more, of course, but then you have an entire virtual CPU for your process available. So if you have more memory, you get more power. So that means that if you say, yeah, and I come to that with that native compilation. So I'm now going to make my Lambda, my AWS Lambda function as that it does not need memory at all. Well, then it does not have CPU to perform its functionality either. So if you need sufficient CPU for your processing, you have more memory. Up to that level that if you have one virtual CPU, which is even enough for running Payara Micro, that you have more than enough memory to get it up and running without any problems. And if you compare it then with JavaScript, with Node.js, for instance, then even the cold startup and the warm startup, so it is already warm, the request times are comparable. JavaScript is maybe still 5 or 10 milliseconds instead of the, I don't know, because it was not Payara Micro, but it was a pure Java function that I remember. It was something like 115 milliseconds, and the JavaScript one, the cold startup, was like 135 or something, which means that yeah, the difference is not that much, of course. And if you're really bothered about the startup time of Payara or Java in general, for instance, you saw yesterday that on my machine, a Payara Micro starts up in around 5 seconds. You can get 30% from 30% reduction from that startup time by just using class data sharing. I'm not going into details what that is, so if you want to know more about it, have a look at it on the internet. But in a few sentences is that when your JVM starts up, it needs to load all your classes. Those are on the class path, in the jar files, etc. They are in a operating system independent way, because they are byte coded, they can be reused on all platforms. So they are loaded, they are verified to see if there is no tampering done with it, to see if, for instance, if you reference another class and interface, if they are available, if the method signatures matches, etc. So there is a lot of housekeeping going on when the JVM starts, which is good because for your own safety and that you know that that everything works as expected later on. But it's, of course, it is overhead. With that class data sharing option, you start up your application before the actual production startup, where you perform all those checks. You load the classes, you perform all the checks, and you create what's called in a archive file. So it is a read-only file, which is also memory mapped. For those that do not know, memory mapped files, that are files that are on your disk, but actually used when they are still on disk directly into your memory within your process space. So when you start up then your application with that class data sharing enabled, you do not need all that verification anymore. It is just referring to that file, which is already in the correct format for your operating system. And that means that you can have a huge startup benefit for Payara Micro, for instance. You can achieve something like 30 to 35% increase. So that's mainly if you're concerned that if you need to start up or that when Kubernetes start up other container, that it goes as fast as possible if you have a need for such kind of functionality in your environment. And of course, you have that native compilation where you convert your Java bytecode to Windows or Mac or Linux executable bytecode. It's faster, needs less memory. Again, think about if you go too low on memory, then you lose CPU power. But there is, for the moment, I'm sure that there will be some improvements in the future. But for the moment, that native compilation, it takes longer than just compiling to bytecode, of course. But also the performance at runtime is lower. Because of the what is it now, 27 years of information and expertise that is in the Java JIT compiler, the just-in-time compiler, the bytecode will be optimized when your application is running. The first time it just uses your code as you have written it in your application, but after 3, after 10, after 20, I don't know the exact amounts, but after an X time that your piece of code is executed, it can optimize a few things. It can inline methods that it does not need to use the stack as much, so it improves there. But also it can say, well, I see now that 95% of the time in the if statement I'm going to the true branch and not a false one. So I perform a native compilation of the true area, but optimized also with that information, with that that it has gathered around the previous calls. And that means that that JIT compiler outperforms the native compiled bytecode of Java. Not at startup itself, because there you have the conversion from bytecode to that it needs to be interpreted. But after some time, and that depends depends in the situation, how many requests are your applications or whatever. But it can be already after a few minutes that your Java JIT compiled application is running more performant than your natively compiled, and it can be up to 10%. So that native compilation, that's fine, but today make sure that you only use it for short-living things like those AWS Lambda functions maybe, and that they are really stopped, for instance, and not kept warm, because you have also other issues with that native compiled Java code. You have issues with reflection. You cannot do lookups as you like within. You can not just do load class, because that native compiled code is what is called closed world. At compile time, everything is fixed. What is possible, you cannot change anything anymore at runtime. So as a conclusion, for if you would doubt about it, so no, Java is not too heavy. It is perfectly suitable for cloud and even AWS Lambdas, functions, etc. In most cases, unless you have a very small service which does not need a lot of CPU, then it can be maybe cheaper and more cost efficient to use something else. But otherwise, no, Java is perfectly fine. And since, well, we as Java developers here, I guess, we know Java well, you don't need to switch to something else for those kind of situations if you want to use serverless, for example. Did that make sense? Again, you can have your own ideas and opinions, and there are, again, as I mentioned, there are always exceptions in situations where one is better over the other one. But yeah, these are the things that you should consider. That's I hope that that at least that is something that I can give you. Any questions around this? Java is too heavy. Comments? If not, then we continue to some code. And the next thing that we see is again something about MicroProfile. So now that we have seen that you probably, or that you might have multiple microservices, and even in a monolith, it can be interesting to use that MicroProfile REST client, because also in a monolith you can you might have the need to call an external service. It's not because it is a monolith that that there are no integrations. And switching back to what we have seen, no, I did not see it yesterday, but let's switch then back to the JAX-RS one. There is also a what's called the JAX-RS client one. So yesterday we discussed the server parts, the annotations, and how you can capture the information, etc., and how to send responses, etc. But you also have a client part. The client part, which then of course means I want to call something externally. I want to call a third-party endpoint, or I can call a other microservice that I have created, for example. First of all, that client you need to, so I've made here the comment here, but to make it clear, this is pure JAX-RS. You need to define a client, and that is a bit expensive. So don't do it for every request that you're sending out. So again, if we have here a CDI bean, then we can do it in that post construct init, and it is only done once, and that client will be used then for the entirety of your application that is running. And this client is thread safe, so it is fine to have a singleton here that it is used. And how are you using that client? Then you specify my client needs to call this target. You specify an URI. You can add some path elements at the end, so you can concatenate it, because you can have some variable parts that comes from a Java instance. Then you create a request out of it. You can specify header values. In this case, it is again that basic authentication that I'm adding here. And then I'm performing in HTTP GET method, and I get a response. Looks perfectly fine. But if you know what MicroProfile REST client can do, then this is really low-level stuff. You say, I have a client, this is my URL, these are my headers. I can specify query parameters, whatever, but it's really low level. It is a one-to-one match to your actual call that you're going to do to that endpoint, URL, headers, get, post, whatever. So it works. And you have a response. So if you have a JSON or a string, then again, you need to handle it yourself. So maybe that can be improved. And that was the idea of the REST client in the MicroProfile specification. it uses behind the scenes this one. So it uses the low level one because it works, as I said, it's fine. But it gives you another way of accessing that, which is quite neat, if you ask me. So no, let's start. So we have two services, service A and service B. That's more or less the same example. If you download that start.microprofile.io, that example program, and you select REST client as then you have that information there within service A and service B. So I have here my remote service. Let's call it service B. It has a URL. It has a path parameter. It returns a string and at a certain URL. Nothing specific, no rocket science, but let's model our client to this server endpoint. And modeling, the best thing you can do with modeling is create an interface. So you see, I have here an interface and a method that has the same information as my server. So I have here a path parameter, I have a path, and I have a get here. The name does not matter, and the name of the parameter here also does not matter at all, because they are in different JVMs and they are not used. But yeah, this name of course does matter because yeah, it's linked with this one. But other than that, it's again free to change it. I'm coming to the other annotations on top of the interface in a moment. First, let's use that one. We inject an interface. By default, if we would not write this one, then CDI would say, sorry, but how can I inject an interface? I don't know how to do that. By adding this REST client, which is from MicroProfile REST client, an annotation, a qualifier, then there is a certain producer triggered. You can link producers, or you can create more or less dynamic producers based on a qualifier. So the producer will create an implementation of that interface. So it creates a proxy, which is capable of calling a remote endpoint with get and these two and this parameter. So when I actually execute this statement, it is not inside the same JVM that I call another method, but I call an external endpoint. And to have it possible that the proxy is generated, I need to also put here register a REST client. And yeah, most of them you want to define the scope. So there is only one proxy, because yeah, that's always independent of the user request, but yeah, you need to specify it explicitly. This I'll explain in a moment. It's not needed for basic functionality. So that means if we have then service B, I do a Maven clean package to be sure, because maybe I did not target is there, but anyway, it does not hurt to do it again. So if I start up service B on a certain port, 8180 in a window, let's use this window for that. I start Payara Micro for that. Then my service A will be started separately from that. And the only thing that we still need to say, where is that location? Okay, it's now localhost 8180. But yeah, that is probably test or production dependent. So it is a nice thing for configuration. So the thing that we have seen yesterday for the config values are used here also. saying this is the fully qualified name of my interface. That's that service here, /mp rest/URL. Or you can now also say URI. And then we specify here where that service is accessible in the environment that I'm working now. So all the information is available. It knows where it is. So if I call this client controller, then that proxy will be able to call my service B, and it returns a value, and just returns it here on the client side. And there's my commands. I made it myself easy, so I'm just going to deploy it here in this case. And this is also the moment where you can see that there is an automatic clustering in action for Payara Micro. You see it found out that there was another instance started, so they are forming now a cluster with two, and they share the information, share some system information, but you can put information in that grid for yourself. You can put cache data there, etc. So you can make use of that clustering capability yourself also within Payara Micro. As I said, I think I said it yesterday, it works out of the box here locally, but also within Docker, within Kubernetes, etc. So it works in all environments out of the box. Sometimes you need to have some functionality, some configuration to have all the functionality, but most of the time it works out of the box. So when I call this URL, so this is called this client with that parameter microstream, I'm doing a remote call to this one where it says I process the parameter value microstream, I returned it, and that's what will be returned by the service A. Proof is always nice. So, and I get my process parameter value microstream. So it went from A to B, back to A, and then I got my response. Sometimes, especially in the beginning, if you are new with it, with that feature, it is sometimes a bit cumbersome to define here what the exact URL is. And then we can make use of functionality in that REST client where we say that we on that proxy we add some additional filters, for instance, request filter, response filters, whatever. So it's not only calling it, but we also add our own logic in this case for the client request filter. So when the client sends out a request, I can, for instance, print out the remote URI that it will be calling. That's what you see here in this output. And then you can see, because as I said, it's taken from various sources. Part is from the configuration, part is from the add path annotations that you define. Some like this one was from the method, the method parameter that you use. So it's a nice way to see, okay, this is what I have ended up with, and yeah, you can then see if that was the correct one. Or if you say, oh no, I forgot theirs, or I had some additional slash which was wrong, etc., etc. That's an easy one. You see, it's also a single line, but it is a client request filter. We can do whatever we want, even modify the entire request, which okay is possible, but I don't recommend those things. And yeah, you can also have a client response filter, etc. Another nice thing of this is you cannot see it here in action, but if I returning JSON, then this REST client from MicroProfile also will convert that JSON string back to a Java project. So you are really no longer confronted with, oh, this is a remote service which uses JSON. And for me, it is also a very good thing to chop up your monolith. Because at a certain point, you might have in your monolith the functionality that this client controller, that this is actually a service within that same monolith, but then you decided to split it out. But this method does not change. That code can stay exactly as it was in your monolith. The only thing that you need to fiddle around is creating maybe that interface and a few annotations, but the actual code can stay intact, and that's a nice thing because yeah, you have worked probably a lot more on your business logic and your code than on all the annotations. So if you don't need to change anything around that piece of your code, then that's nice, of course. Questions so far around this REST client?
So Rudy, I've got a couple of questions about watching you and how you've been starting the services from the command line. My question is, in practice, when there's a problem, we'll want to step through and debug.
Yes.
So do you have to like attach an external debugger in order to get that to work right? Or can you actually start your service from the IDE in debug mode?
Yes, with those IDE plugins that we discussed yesterday, you can not extort it externally, but you can say here, start it in debug or run it in debug mode.
Okay.
But yeah, then you need those plugins from Payara for your environment. Did you have another question around this, or?
It's just, I'm just trying to absorb.
Yeah, I know it's a lot, but
A lot of different things here.
it is recorded, so you can watch some pieces, some snippets. You can rewatch them. You can play with the examples yourself because they are on that GitHub repo also. So.
I have a follow-up question. The two services, if I understood correctly, in the cloud, the way that they're set up architecturally, they have separate JVMs, right?
Correct.
So setting a breakpoint is not, I thought that was within a JVM, right? So if you're setting a breakpoint from the IDE and the the program execution goes over to the other service, which is in a different JVM, are you saying that the IDE is going to let us set breakpoints across both services and you'll be able to watch it in action?
I think in IntelliJ, yeah, even in IntelliJ, you can start your processes twice, and you can attach the debugger twice, once to service A and once to service B, and you can create breakpoints in either A or B, and it stopped there and whatever. So that's perfectly possible, but most of the time you only need to follow up on one of the two.
Got it.
And then you only start, for instance, service B in that remote debugging and see what happens there.
Yeah, that's really straightforward. I think I was thinking too deeply into it.
Yeah, there might be occasions, but even if you are confronted with that, you can always do it in a series of action. You start with, okay, my first request ends up in A, so I start looking there, and then I see, yeah, it seems okay that what happens here in A, but it seems that I get a strange result back from B. So then you start over the debugging process and start debugging the service B side of it.
Great, thank you.
Rudy, Michael here.
Yep.
I'm wondering regarding the Hazelcast data grid you mentioned. How does Payara Micro differ between different services? For example, you started service A, which holds application, a specific application, and then you started service B holding another application, but not the same.
And they
make sense
and they make a cluster, and you say, well, I want only a Hazelcast cluster of everything which is service A, and another cluster which is everything service B. That's what you're also want?
That's what I understand regarding getting applications together into a cluster. But it seems that I can have different applications in one cluster.
You can have the different. Actually, it just clusters Payara micro instances. Actually, it also can also form a cluster with Payara server, and then you can control Payara micro from Payara server, because there you have the admin console, and then you can send remote commands to Payara micro. But that's okay. That's the theory, and it works. But most of the time, indeed, you just have a cluster, yeah, you can have different kind of, you can say the different kind of clusters. Again, Google, help me, Payara micro command line parameters. You can specify the cluster name or something. So if you say that, yeah, I want to have that, here, the cluster name. So if you say that everything of service A needs to be clustered, and everything from service B needs to be clustered, but that they are not allowed to form a cluster cross application, then you just specify a name a proper name for each application, and then you have separate clusters.
Okay, thank you very much.
But yeah, it's also fun to have one big cluster, of course, because that has also benefits. For example, where is here? It is here. So if I put something in the cache, because Payara Micro support that you have caching functionality, which is backed by this Hazelcast. If you put something in the cache, then okay, that's available on Hazelcast, and the next time that service A needs that method, it can retrieve it from the cache. Fine. But what if you stop service A completely? Well, the cache is also available in service B. So by having a shared cluster, then your cache even survives the restart of your service itself, which can be nice.
Yeah. It makes sense, but freaks me a little bit out.
Yeah, it is what you like. This is what you want. Yeah. It is at our scenario, but you can avoid it by this cluster name.
Yeah.
So Rudy, these examples that you've been showing, we should be able to run these in just regular Payara server as well, right?
Yes.
Shouldn't be a difference.
Should be no difference at all.
So could you like run since so that you don't have to install plugins and things, you could theoretically do your debugging and troubleshooting everything in Payara server and then verify it in microserver.
Yep.
And it should be the same.
Probably within Payara server, you are not going to run it with two different IP addresses. So you know, this one was 8180 and the other one here was 8080.
All the different ports, yeah.
But within Payara server, you probably just deploy it on the same port, the same server, and just have the two applications next to each other. Right. So yeah, the URL and the configuration here will need to be tweaked probably, because you're deploying it a bit different. But yes, everything. Wait before I say such a thing, but I guess yes, everything what I see these days works also on server.
Okay.
If, for instance, if you're now thinking, oh yeah, then I can do my development on server and my production on Payara Micro. Yeah, fine, but be aware that there are small differences. Payara server has that by default full, or you need to take the web profile. And even if you take the Payara server web profile, then you are missing, for instance, the concurrency, which is available in Payara Micro. So again, the general rule is in IT, use the same in development, test, and production, the same tools, the same versions, so that also goes here, of course. But yes, it is possible. In practice, it is possible.
Okay, thank you.
REST client has another nice feature. What if this service B might take the execution of that remote code might take some time, or yeah, just is lazy and waits for 2 seconds here in this example. I can of course just wait here in my client until I get my response and then continue doing whatever is needed. But what if I not only need to have the result of that heavy service, but I also need to do something locally, or I need to call even other microservices. So it would be nice if I could use asynchronous in this thing, which is done out of the box. So you see here on service B, it's a regular JAX-RS endpoint. Get, calculates, path. So there is nothing specific. So the idea is you're not in control of service B. So it is there somewhere out in the world and you can call it and you get it back, but you cannot control it to make this, for instance, asynchronous, because that's also a possibility, which I briefly touch. But what if you can make your proxy here that it switches from synchronous to asynchronous automatically? The only thing that you actually need to do here is in your interface, instead of returning the string itself or the POJ or whatever, you get the idea, you return completion stage. And then here, of course, if I then say calculate, I get the completion stage back, which is immediately. So my proxy returns immediately, not waiting for the result to appear again here on the client. So I can continue in my caller. Okay, again, it is just 1 second sleep to, based on the log output that you see more or less the synchronization between the two. And then at some point, yeah, all the functionality here in the client is done, and I want to wait for the result, or maybe the result is already there and I just want to return it. Then I can just say to completable future, so that returns a future, and yeah, you have a get. And this completion stage, that's pure Java. Java util concurrent. Completable future is concurrent. Is from sorry, the future is to completable future is also from concurrent. Yes. That's the main reason why Payara Micro has that concurrency functionality included, because otherwise it could not function this kind of example. So this turns asynchronous call, as we have used it here, into an asynchronous one by just completion stage, and by here using the correct types and return the value when we need it or when we want it. So it's not super clear all the time, because as you know, asynchronous and all those kinds are not always easy to follow, but let's try it. So this is my service A, and it starts with a call to the remote service here at 41 seconds 525. And I received it here on the other hand. I need to make it smaller and that it appears. Oh yeah, it's there. Sorry, you see. And then what is it? About 100 milli? 0.1. Yeah, so 100 milliseconds later, I receive it here. But in the meantime, this one is 41,622. In the meantime, 41,641. This one, service A, is already continuing. So he did send it to here. The moment that he receives it here, and the service B, the service A is already doing other things. At the moment, then it says it is that 1 second later here, it says, okay, I'm now waiting for the result, and it is waiting until it says here, after those 2 seconds, okay, I'm sending back the result, returning the result from the heavy service 43,626, and 40 milliseconds later, it received the result here. That is, for me, also a very nice one, that you can rather easily call a remote service asynchronously. And this is, for me, this is the main benefit if you are doing things asynchronously. In theory, you can also, and that's also a thing that I deliberately skipped yesterday, is doing asynchronously on the server side. But then you also need to use here that completion state. And then you can, for instance, a thread pool. This is a pure JVM thread pool, which is managed by Payara Micro in this case. So that's why it is called a managed executor service. That's also part of Jakarta EE. Also that concurrency, that's also the reason why that is included in Payara Micro. Then you can say, I submit here a background tasks, and that will supply my result for my client when it is ready, and then always say, and then it returns it, but actually this returns happens even before this background job starts, of course. What are the benefits of this kind of, on the server side, this is synchronous? Someone an idea why you would use these kind of things on the server?
The first thing that comes to mind is if you have a lot of hits happening at the same time, you don't want to block. Well, I don't know. You don't want to block it.
Okay, I see what you mean, and I have to tell you some story about how it works in Payara Micro, and then you see that it's, you just shift the block from one level to another, but okay, yeah. Anyone else first before I start the explanation? So yeah, so a bit of and that's already really technical, but probably at some point you need to understand it, how those things works and how you can tune your application and your environment for performance. You need to know that. So that's why I'm going to explain it here. First, you have what's called acceptor threads. So they are actually looking and listening for incoming requests from the clients on that port 8080. These kind of acceptor threads, the amount of threads in that pool are normally the amounts of cores in your machine, because it does not make a lot of sense if you have, for instance, a 2-core machine, to have 8 threads looking for incoming requests, because they have to switch places anyway, because at maximum there can be two running. So that does not make sense to have those acceptor threads, that you have 8 acceptor threads looking for incoming requests. So these acceptor threads, they capture the initial client request, but then immediately hand over to a thread pool, which you can also configure in Payara Server and Payara Micro, which are there your web application thread pool. So that each, and I'm going to use then in normal, between brackets, a normal call, so that this code is executed in that web application thread pool. And yeah, you configure that. I think yeah, you can have 10, 50 or whatever. That depends on the number of concurrent users that you have within your application, concurrent requests. If you have a very large your user base and a lot of concurrent requests to a lot of methods, then yeah, that needs to be higher, because otherwise some requests need to wait. And then I come to your answer saying that, yeah, when you have something blocking, like a database call, a file read or whatever, then yeah, that thread needs to wait until that response is ready. So instead of not having to wait that thread to wait for it, let's put the call to the database or the file in another thread pool and immediately free this one. But what do you do? You shift the blocking from the one which is executing your method to the one who is executing your background task, because there you still have that blocking task. So this entire asynchronous is perfectly fine if everything from A to Z, from the first statement in your client all the way up to everything in the server and back is possibly asynchronous and is non-blocking. From the moment you have one single blocking thing in that entire chain, and databases are one of those things which are still synchronous, then the benefits of the asynchronous are dropped immediately. You have lost all the benefits of that entire asynchronous usage of your code. Do you agree or not, Douglas?
Yeah, that makes sense.
So yes, your answer was correct to not block this thread, but you just block another one. What can be useful here, okay, but not for the string, of course, and you need to do some things additionally, is when you return very large responses. Because when you do it, let's again have an example here. If you just return here, then yeah, it only starts returning data to the client at the moment that yeah, this method is returned, as the system can process, for instance, here what you're going to return. So with this completion stage, you can perform what's called streaming So you can stream already results from the server to the client, and the client can already start processing that result, but the server did not yet finish the entire processing of generating the response. So there, this completion states can be useful, but if you say I'm going to use it to avoid that a thread is blocked, then be careful what you're calling, because it is quite easily to fall in a trap and that you have some blocking communication, etc. And then it is not working as you would expect. Another on that same matter, for those who don't know it, but there is in JDK 19, it will be 19, not 29. There will be the first inclusions of Project Loom from the OpenJDK, which are using virtual threads and how they call it, concurrent and a structured concurrency or something they call it. Because all these threads, what we are using here, are operating system threads, which are quite expensive, and indeed, if you block them, then that's not nice, etc. But for Project Loom, you have virtual threads, which means that Java will have its own threading system on top of the operating system ones, and that could lead to the reduction of the effects of having a blocking I/O in a thread, because it are virtual threads, so it does not have that same impact on your operating system, on your CPU in general. Okay, this was MicroProfile REST clients. So are there any questions about calling remote endpoints, synchronous or asynchronous?
Michael here again. I still have troubles regarding the thread pool you mentioned. Is it possible to define different thread pools to make, for example, heavy calculations?
Yes.
Just only 5 at the same time, for example, and then respond otherwise in case the pool is full. Okay,
but then there is something other useful. You can define your own thread pools for that, but fault tolerance specification of MicroProfile is then something you, and I will briefly explain it. It's something that you can use for that. But yes, you can define current thread pools again. So those ASAdmin commands also works. But here they are on a listener, so that's the thread pool for the listener. But it's also possible to configure the thread pool which is linked to, where was it? No, it was in the XRS one, which is linked, for instance, at such a executor.
Thanks.
But then you need to specify here a name, a certain name. So you need to create a named executor service where you define what is the amount of threads, the amount of workers in that pool, etc., etc.
Okay, but you said fault tolerance is a benefit for this.
Yes.
Okay.
Yes.
Then I wait. Thanks.
Yes. So, unless there are other questions, let's have a 10-minute break, because we have still quite a few things to do. So let's have a 10 minutes break, and then we can continue with that. For example, with that fault tolerance specification of MicroProfile.
All right, sounds good.
Yep. I was just looking here for where do I pause now this recording so that there is not all those breaks in between. So. Ten minutes it is short, but in an hour or so, we have an hour-long break. So hopefully that's then good to get energy back again, because yeah, it was mentioned there is a lot of things mentioned, so it can be, I think, quite challenging to absorb all those things. So I continue with a few other microprofile specifications. I'm not going to show all of them because I have another, for example, another workshop about microprofile alone, which is an entire day on its own, only the microprofile ones. But we covered the two main ones, which are important for writing in code. You have that config and that REST client. That's actually part of your logic, your code that you write. But there are also three specifications: the Open API, the metrics, and the health one, which are more around that automation, that observability that I mentioned yesterday, etc. So Open API, by default, if you just you don't need to do anything specific for that. By default, you already get the definition of your endpoints and some minimal description. For those that Open API does not ring a bell, maybe Swagger does say a bit more. So that's all the entire functionality of Swagger to document your REST endpoints was then standardized in this Open API, and that's now standard. And functionality is of course evolved slightly different, but the idea is the same, that you have a documentation for anyone who wants to use your endpoints, that they know, for example, the endpoints, and okay, it is a get, and there is a parameter is required of type string, etc., so that all that information is available. And also from this kind of schema, that's called also schema, that OpenAPI schema, you can generate clients. So you can generate code that calls these endpoints for you, so that you don't need to hand make them all yourself. And there is, I saw lately, there is also for Open API a generator for that microprofile REST client. So you can ask to generate, maybe I cannot open API generator, maybe this one. You can use then that generator to automatically generate classes that follow that REST client from microprofile principle, to have code that calls your endpoint. This description is okay, it's better than nothing, but it's most of the time not enough. So there are various annotations that you can add on your endpoint itself to add more information, more descriptions, more. You see, you have summary, you have descriptions here, you have all kind of information here. Yeah, it does not make sense here, but I can create a specific schema for certain properties, instead that they are not in line, so that things are reused. You have what it is. You have API responses, so you can have a list of. So you can describe a list of responses. So that means that I'm going to do it a long way to be sure. You have a list of API a response, then it is a single one where you say for response code. For response code 200, I have a disk encryption, but I also return. And I'm not putting my brackets here correctly, so you see sometimes that can be quite some challenge to have the brackets correct. But then you can also have a response that describes my response code. I think it's then like this. It's not numbers, I have it 4, 12, etc. So all that information is then also used to generate a schema like OpenAPI. Useful. Some companies use it, other not, but at least you have something that you can work with. Other thing is around more operational observability. Okay, I have here services running, like this is my service A, but is that running fine? Or is there an issue? And in order to be able to answer that question, we have 2 things. First of all, we have the metrics, the values. What is the system doing? How much CPU is it using? What is the free memory? You can also define your own metrics, of course. That can be metrics that relate to the to your application. For instance, is my thread pool. We discussed that the thread pools earlier. Is my thread pool always 80% full, or is it only 10% full in use, etc., and those kind of things. MicroProfile metrics defines that every runtime, compatible runtime, needs to have a page like this one, the metrics page that describes some predefined values, metrics, and a way of defining your own one. And defining your own one is implementing an interface and putting a certain annotation on that CDI bean so that it can be picked up and it can be added to this list. These are raw values. Maybe some people find it strange to see this kind of format and they say, what is this? Well, actually, this is the Prometheus format. The Prometheus is a product, a time series database, which is, I guess, the de facto standard. There are a few others, but Prometheus is used in a lot of companies. And if you have another product, you can always import data in Prometheus format because, yeah, that's, as I said, I think it is becoming the de facto standard. And it is self-describing in the sense that, okay, you have here yeah, a key, you have a name for it, and then you have the value, the numeric value of it. And for each key, you have already a description of what it is. So you have a gauge or a counter, that are specific terms used in those products, and then you also have an help. So this format is very nice because, yeah, you can import whatever you want. It is self-describing. You can add your own things, and Prometheus can handle that because, and it can nicely show information about it because you define how it is displayed and how it should behave based on this type, like gauge, counter, and you have a few others, I guess. As I said, you can create your own. You can also put some other types of values, which has nothing to do with the system, but more about your business values, number of orders that are placed, the amount of the total amount in euros of all the shopping baskets that were submitted of the orders there, so that you can have some nice graphs immediately or whatever. All those things can be done with MicroProfile metrics. Once they are in Prometheus or in another system, you can create then graphs, for instance, with Grafana. Again, that's a popular one, but whatever is available, that's a whole world on its own. Once the data is there to get some nice graphics and dashboards and things like that. I once helped the customer just on the architectural level, and they created, based on these metrics and on Payara server, they created for their entire server park, which was a few hundred servers, they created some nice custom Grafana images, so they could follow up that 200 servers by just looking at that those few dashboards. But for sometimes a value is not enough. What does 285 mean? Is that good? Is that bad? Is so a value does not say a lot, and especially then for Kubernetes, you need to tell what is the health of your system. Is it running fine or not? And based on this pure data, pure values, well, that's not going to work, of course, because there is no interpretation of those numbers. And that's what's called the health, the MicroProfile health specification. And yeah, the health says, yeah, it is up, so everything is fine, or your system can be down in the sense that it is not down, that it is not responding, but yeah, you have detected yourself that there are some issues with the system. They are also available in Payara server, but also in Payara Micro. For example, one of the checks that that Payara can do for you is the CPU level over time. Is that, and you can configure that, for instance, if that CPU is during the last, let's say 15 seconds, if it's always higher than 80%, then that can be a check. You can have, that is then one of the predefined checks of Payara Micro, which you can activate. That check can then become down, become false, that it's no longer green, which means that the entire status of the server goes down, in the sense that it signals to the outside world of, oh, I'm no longer working as it should be. Again, if you say that 15 seconds of 80% of CPU is a too long period to have such high CPU, that's something that you have to decide. That's the interpretation of the numbers, knowing your system, knowing your environment, knowing what happens. By default, there is this up is based on, is there one application deployed successfully? So this status is also down when in the early beginnings, when I just did Java -jar Payara Micro-jar, then if you go to the health endpoint, you will also see that it is down because there was no application running. Because, okay, I did not specify one, but suppose that during the deployment there was something wrong, because during startup it tries to connect to the network and it failed, etc. So that's also one of the reasons why you can have this health check, and then you can use it. It's mainly used in Kubernetes because that system looks up, oh, and you have multiple one. I forgot now. Someone knows what that are? You have 3 different checks on for the health in Kubernetes when you start up, when you are running, and when there is the 3rd one. You have all sub paths for that here also in Payara Micro. But again, you can create your own health check, and based on the metrics or based on whatever logic that you want. Again, it's a class implementing an interface, and CDI bean annotation with a specific annotation for the health, and then it is picked up automatically by the system. It is important, these kind of things, Open API, documentation, metrics, health, to have a successful rollout in your entire system, because it is more than just developing, but have a look at those documentations. You can find the documentations of the specifications and how it works online, and then yeah, it's not that super difficult to do, so you probably can find it out yourself. You just need to know that it exists, probably. Okay, live and ready. Yes, thank you. You're ready. You don't see any the difference because the system is now live and ready at etc. But those are the sub URLs. Any other questions about that? Yeah, more that operational part, which, as I mentioned in the beginning, cloud native is also that operational, that automation. So if you're doing if you automate everything, then yeah, you need to check if systems are up and running, if they are doing fine, all those kind of things. So that's part of the cloud native.
Rudy, Michael here again. I found in documentation a few weeks ago that there is some kind of health check within Payara Micro as well. But as far as I understood, it's not a combination with the MicroProfile health. Is this right? Or did I get it wrong?
Because I thought now in one of the versions, they said that the default Payara server and micro health checks, that you can expose them through MicroProfile health.
Oh, okay.
And I
maybe
thought,
I missed this in the documentation.
Yeah,
I'm not sure.
There should be that one, and if you do it on the always do it in the command line with micro, you have to specify a certain additional parameter in the asadmin command to indeed expose, like I said, expose that the CPU check for 15 minutes of 80% is also here exposed at the health endpoint.
Okay, thank you. I will check once again.
Yeah.
In this case, yeah.
If that's not the case, then yeah, either on the forum at Payara forum, or yeah, if you happen to be a customer, then you can ask those questions, of course, in the dedicated tools.
Okay, thanks.
From what I remember, they added a lot of things that the default checks, like that CPU check, is also exposable through that health, and then it appears here. And I think I even demonstrated for a customer like 6 or 9 months ago, so that should work. Okay, any other questions before we go then to the fault tolerance? I'm not going to show the examples, but they are quite good explained. If you again, that's always jumped. That was on purpose. The order of the runtimes. So if you check here default tolerance, then in your generated project there are a few examples around fault tolerance included. And yeah, fault tolerance is added to the mix because microservices are a distributed system. And for those that don't know the term, it's a good read. Go look it up at the 7 fallacies of distributed computing. You find it very easily. Wikipedia, 7 fallacies distributed computing. And here there are 8. I thought that there were only 7, but okay. Because you're in a distributed environment, one of those things will always hit you at a certain moment, and that all those 8 points are not of any importance or much less important in a monolith. Because you have microservices, you have latencies because you call external, so you have overhead there, you have bandwidth, so you have lim, and so it can be slower. That topology changes, so microservices change from places, change from host, etc., and all those things. So it will happen. It will. The network goes down. So you always are confronted with those kind of problems. So we need to have some resistance against those problems. Let's add some tools, some ways of mitigating a few of them. That can be that we retry, because it can be a glitch of the network that something failed, and if we retry it will work. If it takes too long, that we do something alternative, etc. And that fault tolerance specification of MicroProfile is then a set of annotations to make all those things, to implement all those things. And I have put here the main ones, and because there was a question, I'm going to discuss the bulkhead a bit more. No, is it? It is the bulkhead, but the description, I guess, is wrong. Anyway, yeah, one of the things, as I said, at timeout, you are willing to wait, let's say 700 milliseconds before a response is back from the remote service. But if not, then you return a cached value or return the value for, or this part of the system is not working. The classic things of a UI which works with microservices in the background is that you see that at some point you see that parts of your screen says, oh, this is not available for the moment, or retry in a moment, and those kind of things. That's something that you can do if you have a timeout, that you say, okay, to the user, sorry, I cannot give it to you for the moment, or and then the return, and that the fallback return a constant, a default value, or a default text, and those kind of things. Retry, knowing that, for instance, as I said, network is maybe flaky to some external party, that you say, yeah, I know it failed, but let's try it again, probably it will work then. Don't use retry blindly, because if you just say retry everything for a few times, then yeah, then if it's not working, then yeah, it's probably not going to be better the next time. Circuit breaker is a bit of a advanced version of retry. Circuit breaker is like the circuit breaker in the electrical circuit breaker in your house, in your electrical box there, or how do you call it in your house. You can try it and it works fine, and then the remote service fails, and at that point your circuit breaker goes off, and the next time you don't even try to call your remote service, but you wait for a certain time. That can be a second, a minute, whatever, that's configurable. And after that time you try it again, see, oh, is it fixed now? So let's see if I can call it again. And bulkhead is for that to prevent the overload. As there was a question, can you configure the thread pool for a certain thing? I always now explained, as you heard in this example, I call the remote service, but actually these are CDI interceptors. So you can use that on any method within a CDI bin that does not need to be something related to a remote service that you're calling. So actually that bulkhead here, for instance, can also be used to, even when you're not using an external system, to protect your own code, saying, okay, if I have probably here a denial of service attack, then don't try to answer to 1,000 requests at the same time, but just do 5, and then the rest says, sorry, you're not in today, and those kind of things. Going a bit deeper then in that bulkhead, because that was a specific question. For instance, you have, okay, this is because it is remote with the connection and it return connection, but okay, it can be anything. It says bulkhead 5, meaning only 5 threads can be within this method. If a 6th thread tries to access it, it needs to wait until one of the other 5 has finished executing the method. That's a basic protection that you can do if you know that there is here some sensitive, in the mean sensitive, if there is some critical thing that can take some time, that can be overloaded, that should not be called by 100 users at the same time, etc. This is the way how you can protect those kind of things. But you can actually have this in a thread pool, so that your the thread which is calling that is actually just handing over it to a worker in a thread pool, and that's it, and it waits for the response afterwards. By just putting here is synchronous and saying then you can still say I have 5 workers, so I can still have 5 people using that method, but if there are more, then they come in a waiting queue in the queue up until 8. So that means number 14, person number 14, they will be rejected by a bulkhead exception. And this bulkhead can be combined with fallback, etc. So that means, for instance, that fallback that you can return a default reply if it fails. Okay, it is brief. Also, fault tolerance is a good one. It's not needed, I guess, in all applications, but in many applications, you can benefit from those annotations and those principles here. Timeout, retry, fallback, etc. So have a look at the description of each of them, like we did with the bulkhead, and it's always tricky to test that because you need to have a specific scenario, like with that bulkhead, you need to have, for instance, 6 concurrent requests. So you need to have the way to provide them. They take long enough so that actually they are still executing the 5 previous one, etc. So testing these things can be a bit cumbersome and tricky sometimes, but it is possible. But I guess you should rely on the fact if you put those annotations there, that it works and that you're safe. Questions? As I said, you can play around with, if you select here fault tolerant in the starter, then you get an example for many of them. Not for all, but there are many, and otherwise you can find always information on the internet about it. Let's stop then all these things because we are now done with MicroProfile. Yeah, the last one is, I did not mention it. Is it on the slides? Health and metrics is there. Yeah, you have MicroProfile JOT, the JWT tokens. Because that is basically the only security framework that works with REST and with microservices. Why do I say that? First of all, remember REST is stateless, so each request you need to provide with each request enough information so that the server knows who is calling it and what is your question and what are the parameters. So that means that if you want to know the user, then you need to specify the user, some user identification each time. And yeah, you can maybe, as some people say, yeah, I can use a session ID for that, for instance. Then it can be looked up centrally or in a system who is linked with that session ID. Yeah, okay, correct. But there are two problems with that. One, you assume that all those requests are only internally for you, so that the session ID that you have here that you've received, that you can look up in your own environment. Because if you just receive a session ID from a remote system, yeah, then are you going to be able to get information from that remote system? Then who is the person with ID 123? I guess not, because yeah, that's, of course, anyone can request that, and then you have an issue. Secondly, the problem with those session ID is, like I said, you need to go to a central system, so you can overload them. The idea is also that microservices are independently or as isolated as possible. They don't look they don't have the need to look at other systems like an LDAP server or whatever to retrieve information. Everything needs to be available within the request, and it needs to be able to verify the things locally without consulting external systems, external services. That means that those JWT tokens, long name is JSON Web Tokens, that they are ideal for that, because again, not going into detail because that will lead again until an entire discussion for an entire day. But those JSON Web Tokens, you can send information that they contain information about anything. It's a payload. You can specify a JSON object there in the body. But they are signed with a cryptographic key, a private public key pair, RSA for example. That is very common, but also elliptical curves or all the others are also supported. Because it is signed, means that if someone tries to change that JSON in the body, because that's readable by anyone, if someone tries to change it, then when you verify the signing, you will see that, okay, this is not the original, that the signature does not match with the payload, and that you can just reject that token and say, nope, that's not going to work, hacker. I'm just saying 401 authentication required because it was invalid. So you only need to, your service only needs to have the public key to verify with that signature. That needs to be retrieved from the system that has created and emitted those tokens, but that's not for every call. Those keys do rotate, but that's not every minute. Some people only do it every week or something, so to rotate those keys. So that means that only once a week your microservice needs to contact that central system to give me all the public keys that you have in use now, so that I can verify those tokens that you have signed with your private key, which is of course kept within the system. It's not distributed. Within the JSON, you can put claims, as they call it. You can, which is just JSON property key value pairs, which can include the name of the user. They can include groups and roles. So what permissions does the user has, and then you can use that in your own application. MicroProfile JWT authentication implements on top of those Jose specification, because there's also specification that those entire signed and encrypted. You can also have encrypted tokens, but in some areas they are restrictive, more restrictive than the specification says. For instance, you cannot use any kind of combination with MicroProfile JWT. You can say, oh, I only support one kind of signature algorithm, RSA 256 or something, but I don't allow, I cannot say I'm allowing signing and encryption at the same time. So I made a few comments on that project the last month or so, because yeah, they are a bit too restrictive, and it looks more than a distributed monolith than a real microservice thing. Because if you have a microservice, then you should be able to use that anyone can call it, and as long as it is a valid token which conforms all those things and issuer and all those things, well, then that is fine. Don't try to be so protective and make it it's not that it's not usable, but some environments cannot use MicroProfile JWT specification because they have used those restrictions. It's an entire day, as I said, again, if I explain everything with examples. So maybe a shameless plug now here. So I also give these kind of trainings around security, MicroProfile, JWT token. So if you're interested, you can always contact me. So that was a bit MicroProfile. Most important aspects are covered. Really helpful for your cloud native microservices, or in general, your applications. In general, I use it all the time. Questions, or do we cover data access? I guess it will be data access. And I'm going to cover the topic databases and JPA, not because I'm just as I did with JAXRS. I'm not going to explain entire JPA specification, because probably you all are familiar with it. Maybe not. I'm not sure if that person is still on today, and that was using Spring. But then you have also Hibernate, which is also following that JPA specification. So it is possible that you are already experts in JPA. The main thing I want to show you about the database in JPA is how do you combine it with Payara Micro? How do you configure Payara Micro and your application so that you can make use of a database? Or there are also possibility to use other NoSQL solutions also in more or less the same way. So it is a general thing that you can make use of it. And then after the break, the long break, I jump to MicroStream, where we are going to talk as an alternative for databases, because if you are just using a database to store the data without any additional functionality, I mean, without any features, just, yeah, I need the data there so that my process can be restarted. Well, if that's your database usage, then MicroStream is better suited because the JVM memory is used as a database there. And it has of course, a solution for the fact that if you restart your Payara Micro, that you did not lose your data. But first, how do you combine databases with Payara Micro? Do I need to explain this? I guess we all know that. What is ORM, relational mapping on top of JDBC, etc. I think we all know that. But it can be challenging to retrieve the data with an acceptable performance. You have that n+n query problem. You have to define the mapping, which where the mapping does not match, in the sense that yeah, there is someone raising his hand, a question, so go ahead. Or was it by accident?
Sorry, Rudy.
Yep. No, no problem.
Okay. I want to take you to the previous slide about JWT.
Okay. Yeah.
Yeah. I had this problem with JWT on Java. I was wondering how I can sign out the token when it is not expired. Can you please try explain to me how I can sign it out? Let's say I've set the time for 15 minutes for the token to expire, but in 5 minutes I want to sign out the session.
Yeah. That's indeed a bit difficult with JWT. It is in theory possible, but it's not common. And I don't think that every provider supports it. So as I said, there is a third party, a server that can be, there are many. They create those JWT tokens, and they indeed say they expire in, for instance, 15 minutes, etc. But each token has also a unique ID. You have the JTI claim, which is a unique ID. So if your environment, if your system supports that you can cancel what's called revoke, if you revoke a token, then yeah, the only thing that you can do as a microservice to check that is make a call to the server every time to ask, is this token still valid? Is this token with this ID still valid? Which is not ideal. But the token itself, yeah, once the token is created, it is immutable. You cannot change it, because then, of course, this signature does not match anymore. So in the token itself, you cannot indicate that it is revoked. So you always need to contact the server who created that token to ask, is this still valid, yes or no? That's a solution, but yeah, it's not common in the environments that we are talking about now, that you say, okay, I create a token, and yeah, after sometimes I want to revoke it. If you have those scenarios, then instead of maybe using tokens of 15 minutes, configure the entire system to create tokens of 5 minutes. Because then after 5 minutes, then yeah, in any case, that token will not be valid. And if it's not renewed for a new token, then the user will not have a valid token anymore. Does that make sense?
Yeah, it makes sense.
But what you explicitly say, can I check for a revoked token? Yes, but yeah, you have to contact the server. And
But
not,
I understand the token is not stored in the server as it is stateless.
yeah,
And it's only stored in the client. How can one check?
Yeah, but the server, as I said, if the server support the server at the yeah, it's the server in the sense that you have those for instance OAuth 2. So every OAuth 2 server generates also JWT tokens. So let's put an example for a name, because I have a bit of a blank now of a name. Is he not going to give me just a simple name of a server? Google, for instance, okay, but yeah, you have, for instance, Auth0. You have Auth0, which provides you with a token. That's a cloud provider, and you can log in on their page and you receive a token. And indeed, it is at that moment the client, and the client submits that, for instance, to your microservices service. But if you as an admin say within the admin pages of your area of Auth0, this token is now invalid, revoked, then Auth0 knows that a certain token is revoked with that unique ID. And you as a microservice can call Auth0 to query the system saying, is this token with this unique ID, is that still valid, yes or no? Is it revoked, yes or no? Does that make sense?
Yeah, it makes sense. Thank you.
So, but yeah, you need some specific functionality because yeah, the client, it is stateless, so the client has the token, but it does not know that it is revoked, and the microservice itself also does not know it by default. It needs to check on that system like Auth0, is it revoked, yes or no?
Okay, thank you.
But as I said, it's not common. The idea is, okay, you create a token, and yeah, the token is out in the world, and you have to live with it, and you have to wait until it is expired, which once was an issue because I think it was Twitter, but don't take me on that, that initially created tokens which never expired. So they made a mistake, and they created tokens which never expire, which of course is a super bad thing, because yeah, if someone grabs that token, then you can use it for life to access someone, his data, etc. They found a way around it, but okay, the idea is of that it is not a good thing. I was telling about JPA, ORM standards, JDBC, we probably all know that, and that it can be challenging to create applications. And sometimes if I look back at the project that I did, sometimes developers spend half of their time on how do we store the data, how do we write the queries, how do we write those mappings, the caching, and how do we make it performant, etc. So yeah, it can be sometimes take a lot of work and time to make it work with the database, and sometimes it is what it is. But as I said, with MicroStream, yeah, it is just Java object, so that might be much easier. So not going to concentrate on JPA, as I said, you probably also know that, but what do you need to have it for Payara Micro? In order that it runs with Payara Micro, at least you need to know the database server location. You all know that database URL at the JDBC URL. That's something that you need to know. You need to have the credentials, and you need some configuration options. There are most of the time a ton of configuration options for a specific database that you can configure or leave the defaults, of course. So that's what you need. And of course, it's specific JDBC driver support for the database. Because JDBC is a standard within Java, JPA is a standard, but how the communication is between your Java program and the database itself, how data is inserted in the tables, retrieved by a select, that is not defined by any specification. So that means that you need to have a specific driver for Oracle or MySQL or Postgres or MariaDB or DB or whatever. You need a specific driver. All these drivers need to be added. So Payara Micro comes with no driver at all, just like Payara Server comes with no driver at all. There you have the H2 database by default internally. But yeah, you need to add the JDBC driver. So that's also something that I will show you how you use that with Payara Micro, how you add the JDBC driver so that you can connect the database. And together with the entire configuration. It's not that difficult, but yeah, you need to know it, and then it is simple. Like many things, if you know it, it is. So that is in the demos, also on that GitHub. We have I have created a few examples. I'll briefly touch a few of them, but not going into detail into JPS on it. There is the possibility that you include your JDBC driver within your web, within your WAR file, within your web archive, but I'm not a fan of that. Also because, as we discussed yesterday, that JDBC driver is not going to change. So why include something that is not going to change with every build of your application? You can perfectly keep it outside of it, as you will see it. So the application itself only depends on the standard Jakarta EE web and JPA, and JDBC is part of Java SE still. So you all have that, all those capabilities available by just adding this one dependency. So not having the JDBC driver in your WAR file. You all know that you need to specify a persistence XML file. Most of the time, one unit. You can have multiple units. If there is only one unit, the name does not matter because you're not going to use it in your application, in your code. But you have a unit, and in persistence units defines then a connection to a database, or you can have two units pointing to two schemas of the same database, but actually they are considered as two different databases. So one unit points to one database. Now I'm going to think, and I'm not 100% sure, but in the web profile, you cannot have those, how is it called? Those distributed transactions that you do at transaction which spans multiple databases. So that's only in the full. I think in the web you only can you can start a transaction and commit one, but that's limited to one database. It cannot span multiple ones. So that if you do one commit, that and the record is inserted in database A and also committed in and another record committed in the database B, that is not possible in the web profile. So not possible with Payara Micro. But most of the time, most applications don't need that kind of transaction support. You need a JTA data source, this Java transaction API, data source. So this is the location. This is a GNDI name where it can find the connection, or in Payara Micro, it is a connection pool by default to that database. So it is just a name. Here you do not specify, for instance, the JDBC URL, not the credentials, whatever. It's just a reference, a lookup of the connection or the connection pool. And then you have properties, properties which are fine here now for testing, but don't do this in production. The drop of the entire, all the tables and recreate them when you start your application. That would be horrible. Yeah, but here it automatically creates then, of course, the tables that I need for my example. And within that SQL file, I add here a few records in that database. And sometimes nice, I will you will see it. Payara Server and Payara Micro have Eclipse link. That's one of those implementations of JPA included by default. So you can say that it needs to show a lot of info, which is very helpful, very useful in development, because then you see, for instance, which queries it is creating and executing, and then you can see if you have done a good job in mapping and creating queries, etc. This is, of course, not for production, but you can use a placeholder. I'm going to show it you in a moment, so that you don't need to change the value if you go to production, because this generates, of course, a lot of log if you keep it in production like this. So this is for JPA, so that it knows which connection does it need to use, and then the last thing that we need to configure is that connection pool, that GNDI and name, and that's possible here with an annotation. There are I think 3 different ways in total with Jakarta EE to define your data source. Also external with Payara Server, you most of the time do it externally, so that you do it with an AZMIN command, for example. You can set it as you can do it most with Payara Server. You're going to do it with AZMIN. You can also do that Payara Micro. You remember that post-boot command file that I showed you yesterday, where you can execute those commands. It's also possible here. This is an alternative. That's the reason why I chose it. That you define not the actual values, but that you say, okay, I need to have some GNDI name, which is the same one which I use in the persistence XML file. And yeah, it's using this JDBC driver, which will be available at runtime. And it has a few parameters for URL, JDBC URL, username and password. And I configure immediately my pool size, minimum 2 and maximum 4. So that, again, that's probably not really production one, so maybe 40, depending on what your database can handle, of course. And what your application needs to handle concurrent access to the database. And as you can see, these are placeholders for configuration values. Configuration values that are looked up in MicroProfile config. Through MicroProfile config. So I have, for convenience, I have no, I have not put them here. So I did it properly. So you can have them, of course, that MicroProfile config property files and then define them here. But then again, it is within the application, which is not good. I'm going to show you how you can specify them so that the URL, username and password are properly used for that one. First of all, and that's then the first introduction of Docker. I always use Docker for those databases and the external systems. Then it is easy to set up, and I don't have all those systems on my machine installed. It is just Docker and I have a database. And then how do I launch now the application? If there is something unclear because I go too fast, interrupt me. But if not, I'm just continuing what I was telling. So you all know Java Manager Payara Micro. That's how you start Payara Micro. And here the last one is my application. We know that also. The way of adding the JDBC driver is here with this option, the add libs. With the add libs, we can specify one or multiple jar files, and it can be JDBC drivers, but it can be anything which you want to be available for Payara Micro, but are not included in the WAR file. So here I specify to keep my JDBC driver out of the WAR file. This will not change, at least not daily, weekly, or even monthly. So I'll keep this outside of my WAR file. I use it in the scripting that will start on my environment where I say this is my JDBC driver. Yes, besides the jar file and the WAR file, you need then a third jar file somewhere that you need to maintain and probably copy, etc. But again, for layers, if you're using Docker, first of all, it is scripted, so it should not be a problem. And secondly, it is more efficient. And then the last thing is specifying those property files. As I said, MicroProfile property files. I used a file here called MicroProfile properties, just a key value pairs, username, password. Yes, I'm not using my real password here, but just something that I created here, and my JDBC URL. You can, instead of using system or environment options, because as you remember, MicroProfile config can read from those. I'm going, instead of having here maybe 5, 10, 20 in the worst case scenario, I'm just going to specify that every property in that file will be added dynamically as a system property. So it is like I do a minus D, what was it? My minus D ds underscore u username. Instead of those things, I'm doing it through this command option. They end up as a system property, which means they can be read by MicroProfile config, which we say here that it needs to look, it needs to resolve this, the content of this at start time needs to resolve it from MicroProfile config. This is coming here there because you can also have maybe that you explicitly want to resolve it from a Kubernetes secrets or whatever. That's then also something that you here can specify explicitly, or you can leave it to MicroProfile config to find out where it is, including Kubernetes secrets with Payara Micro. So let me launch this. See, our command line becomes longer and longer, but we are doing more advanced stuff. There was an error here. I hope that it's not critical. No, it is because it tries to delete tables. Yeah, it is started. And you also see that yeah, that the inserts that the inserts are happening, and that's because I have that finest level for the Eclipse link. If you want to use Hibernate, that's also possible. You can use also Hibernate with Payara Server and Payara Micro. You need also with that, yeah, for Hibernate is probably the easiest to include it in the WAR file. I think it's also possible with it with the adlibs. But yeah, if you're in need of Hibernate specifically, which is yeah okay in some cases, but I always if they ask me those kind of questions, then I always say that you carefully need to think about are you going to limit yourself to a certain implementation and not to the standards? Because API is a standard. If you say I'm going to use Hibernate and I'm using Hibernate specific things, then it does not work anymore if you switch from runtime or and those things. So the application was deployed. I have a few endpoints, and then yeah, just read with a parameter. We can just do a curl, and then it reads from the database. You see, as I said, it prints out the query that it has performed, and you can even with another property, with another configuration parameter, print out the actual value of this question mark. So, but yeah, in this case it was 1, of course, but you can also print that out. Are there any questions about using a database with Payara Micro? Because that was the main focus of this demo. Okay, I have a bit of faster detail. I have a converter also, etc. For those who are not really familiar with JPA, etc., you can have a look at it. But the main focus of this example was explaining all the different parts here, and the system properties, adlibs, and here that data source definition. Any other burning question before we go for the
Rudy,
break?
yeah, hey, this is Pat. I have a question. Is the MP config there on line 10, is that a convention?
No, that's Payara Micro. Good question, but if that, good question. Data source data source definition is, you see, JavaX annotation SQL. So that is Jakarta EE. But strangely enough, Jakarta EE allows a string, but that means that you can only have constants, which is not really useful. Yeah, because your database connection will be different in test and production.
Got it.
So Payara made it possible that you use something like MicroProfile config here. It also makes it possible every XML file. So you have the web XML file, you have the persistence XML file, you can use there exactly the same. So you can also say, look this value up from MicroProfile config, for instance, logging level. Then it's going to look at the config property somewhere, and it was now in a file, to have here the actual value. So that's one of the nice, also one of the nice things that Payara does and Payara Micro does, that you can, every official file, like this persistence XML, the web XML, you have the application, if I remember application something, you have the EGB XML file at Payara server, etc. All those things, you can use placeholders there.
That's pretty cool. Thank you.
Anyone?
Hi, my name is Adrian. Can you hear me?
Hello.
I have a question about the persistence XML that you have
Yes.
showed us. I had a problem because, for example, the Oracle database had different properties, for example, and other properties, for example, that MySQL, and it is common, yeah?
That's common,
different.
yes.
Yes. Okay. Okay. So thank you.
Yeah. No. In these properties are properties for your
specified for database engine. Yeah.
Yeah.
Okay.
These properties are used in 3 ways actually. You see that there are some standards, one from Jakarta itself, because this says drop and create the database and execute this SQL file when the database is ready. these properties are also used by the implementation, Eclipse Link, Hibernate, whatever, to do some configuration. But these properties are also used by the JDBC driver. So yes, they are Oracle specific. So you can, I don't know what is there specific for Oracle, but what, as I said, there are a ton of options always, but all those JDBC driver specific ones are also read from this properties list file. Yes, but that means that if there is something specific for Oracle, it will not work for MySQL. It will be just ignored even. Yeah, because it does not, the MySQL driver does not understand that Oracle property file.
Okay.
If there are no other questions, but it's fine if you have other questions. It's, of course, it is on top of the hour, but if there are no other questions, then we have a 1 hour break. And then this afternoon, we continue with that microstream story, and we spend some time on Docker images and integration testing. So no questions, then see you in an hour for the second half of the day.
All right, thank you, Ruby.
So welcome back, everyone. It's the last block, the last 3 hours of the workshop here around Payara Micro. And yeah, we have still a few interesting topics, if you ask me, that we are going to cover. First is that a question about data storage, database, and its database is perfectly fine. I'm not saying that database is something wrong, but as you look at that example, that exercise of yesterday, that shop where we have a list of products and user, etc. And we can easily define somewhere an instance where we have that list, maybe not that functionality here within this class, but yeah, it's not a solution. But okay, I cannot show you. But yeah, so we can access the information in these items by using getters, using the stream API on this product, for instance, and doing filtering on product type and etc. And so we can add a list, we can delete it, and etc. So we are all so familiar with Java and handling data structures. There are a lot of good APIs also in the Java itself, the Java language itself. For instance, with the addition of stream APIs, there are a few nice things possible now. So why not consider this as your database, as your primary source of your data? That's the idea of MicroStream, that not your database is your primary source, and that's external. So that means that you need to read it within the JVM, within your process, that you need to make some copies, mappings, etc. But your JVM is your primary database. So let's explore that idea, and that's also what the people of MicroStream did something like 7 or 8 years ago. They started with that. And let's see what the result is today. It's still evolving. It's still a work in progress, more or less. But for instance, I will tell you one of the limitations that it has for the moment. But there are already nice possibilities. And so the Java objects itself are the database, the primary source of the data. It's not that it's stored externally and used inside. It is the JVM itself. Of course, when your, for instance, Payara Micro instance stops, then all data is gone. So we need to make sure that data is persisted somewhere, that it is stored somewhere so that it can be read again when the instance starts again, and that's done by the storage manager within MicroStream. So it is there in Java, but every change that you make, they say, okay, I've now made a change to a certain object, and then that storage manager will make sure that it will be stored somewhere in a format. More on that in a moment. It will be stored somewhere so that next time it will find it again, and when your process starts again, the entire object, all the objects are again restored, a bit like, or rehydrated, or how you call it, as it was at the moment that you stopped your Payara Micro instance. And why is that maybe a good idea? Because within Java you have objects, and you have an object graph, and you have links between objects, etc. You can have multiple ones and whatever. But the idea of the way how you store data within Java through that object graph is most of the time completely different from how you store data in a database. The database, you have tables, you have fields, you have also a foreign key for the relations, but the structure, most of the time, it does not match how you store your objects. Moreover, because we know that we need to store it at some point in the database, we are most of the time structuring our data not the optimal way in Java, like we should do, but in a way that is compatible with where we want to store it in the database, with more or less like table structure. You have those entities, and then you have those links, etc. But maybe you want to use a completely other structure in Java, which is better, more efficient to look at, to search, etc. But that's maybe not possible because you have that what's called impedance mismatch. Yeah, those two don't match. The way how you store Java as objects in an object relational way is not the same as you store data in tables. All kinds of mismatches they are mentioned there: granularity, subtypes, identity, associations, etc. So granularity means the number of the one-to-manys, etc. Because you also have in your Java objects, you have most of the time bidirectional links, so that your parent has a link to all the childs it knows of, and that child knows the parent, etc. In databases, there is only a link from the child to the parent. Also, identity mismatches. It is required, for instance, for JPA, and it is recommendation that you have a primary key. And that primary key should not mean anything. It should not have a business value. It should be just a sequence or incremental number, or even a unique number which is auto-generated. But yeah, that's purely for your database, because in your Java, you identify objects based on the business values. Most of the time, the values, the variables that you use in your equals and hash code. So they don't match the way how you identify things, etc. the last one, the type, the data type, the differences. The database can, of course, store numbers and strings, etc. But yeah, how does it store POJOs? Then you have those converters, which I briefly mentioned that in the example that I have created also. So a database table cannot store any kind of data that you can represent in Java. So there are a lot of things which, as I mentioned, makes that at some projects, depending, of course, on the nature of the project, etc., that developers spend a lot of time of creating that mapping and making that mapping works perfectly, that you can create queries which can be executed performant, etc., etc., which all disappears if you are just using the JVM, because there you only have stream APIs, the getters and equals and all the checks that you can do with Java. And yeah, going back here, if you say, well, yeah, that's the reason why NoSQL was started some years ago. Yes, that's true, but also NoSQL, the NoSQL solutions does not solve the entire problem here, because sometimes the NoSQL is just a key value store or JSON or whatever, and that might be an easier way to map the data, but I also need to map it. I also need to read it externally. So part of the problem is still there also with NoSQL solutions. So the idea is objects are the main and only source. Your object graph in Java, so they are in your JVM memory, but it needs to survive a process restart. So that entire object graph, you also store it. First idea was it of the MicroStream people to store it just in a file. And later on, people said, yeah, but we have already databases and we cannot do without databases, and that's true probably. Why don't store it? Why you don't store it also in the database? So it's now also possible to store that object graph in the database, but not as tables and fields, just as a binary. Come to that also later, as a binary representation of that object graph, and you can store it there. And actually, for the decoder here, if it's in a database or a file, it does not matter. There is an abstraction created here. It's called the abstract file system, so that you can have multiple implementations of that system. And yeah, one implementation by default, no, there are two, but one is that you can store it to files. The other one is a database. And by just serializing those objects, then yeah, of course you don't have the conversion required. You don't have that mapping. You don't need to convert it to a specific data type that the database supports, etc. So that's all gone. You don't need to worry about that anymore. It's also very fast. Querying data is fast because it is in memory. It's just querying objects, stream API, getters, whatever method is available. So it looks very nice, it looks very promising. There are, of course, edge cases. There are, of course, tricky things, and some of them we will mention. So that it is a possible solution, but of course not the silver bullet, and that means that your databases are still of value and will not be dropped by next year and replaced entirely by MicroStream. We know that, of course, also. Where can you store it for that? So these are all the data storages that are supported either in the open source version, because MicroStream is, the basic things are open source, but some of the support, like the MySQL database, the Oracle database support, etc. And those cloud objects storages, they are only for enterprise users. But yeah, there is a list of databases that are supported by default, but there, if you implemented those interfaces, then you could support any kind of database. You can support a lot of the so-called NoSQL solutions, the in-memory database like Hazelcast, also part of Payara, MongoDB and the Redis cache, Kafka, etc. Is all supported, and those cloud object storage, which means that you can just dump that binary content somewhere. It needs to be kept somewhere. That's the only requirement. So S3 storages and blob storages from Microsoft Azure are then also available then for enterprise users. And you just need to store that binary content somewhere. I will tell that in a moment. Is there already a question that comes up, probably, of about the idea of storing object graphs from Java binary somewhere to survive a process restart?
Is this typically stored at the like the regular, like you in your slide you mentioned RDBMS, so is it like stored at the database level, or just a binary file, like kind of serialization and deserialization for process restarts?
In both cases, it is just a serialization, and so it is also binary as a blob within the database.
Okay.
I actually don't have that statistic. That's a good question. I should ask that. What is most popular, if it's just file storage or blob storage in general, like those cloud storage ways, or the database? I have no idea, sorry, I cannot answer that question. I know that both are used, but is one now more popular than the other? I don't have that info.
Okay. Okay.
Rudy, hey, Pat here.
Yes.
Do you have any thumb rules or about whether how much storage the binary representation of a typical entity, is compared to the native RDBMS implementations? I'm assuming that, the binaries are going to use more storage than if you were to take that state and persist it. Is there, is there like a thumb rule or industry research on that, or just approximate how much more it takes in general? Or when it's used, like if you have to ever take that into consideration, or do you have to weigh?
For instance, just a rough, to have a rough idea, if I store 1,000 users in the database, or I store 1,000 objects, what is the size difference? That's what you're referring to.
Yes.
Yes.
Yeah.
No, I don't have those values because it should not be that difficult. So at some point maybe I should do that exercise to see how much space an X amount of records uses in the database, and then the binaries. I'll touch briefly that topic about size and speed of serialized data later on in a moment. But yeah, no, I don't have an my first guess would say yes, it is a bit larger, but not that much. Because
have you used it on any projects yet?
Myself, because
yeah.
I'm only working an X amount of months for MicroStream. No, I've not used it in a real world project, but it is used in real world project, that's for sure. So there are several customers of my MicroStream that are already using it. Also some big ones like an airport, for example. But
would you
yeah.
say it's still at the cutting edge, bleeding edge, or is it pretty good, you know, solid,
Well,
been around a while, works good?
It is taking up speed. It is, as I said, it was started 7 years ago or something. I think it's now, what was it, by InfoQ promoted to innovator, or what was it? So that, or an early adopter or something. So it is gaining more and more traction, but yeah, it's not mainstream yet in that sense. So it is, we are not at that level yet. So yeah, it's still a bit of cutting edge people who try it out, but everyone seems to be pretty exciting about the technology, also on conferences, etc. And everyone sees a lot of potential and value in it.
I'm wondering if it would be better, you know, best, ideally suited, you know, for scientific applications. But it's, you said there are airports using it, but I'm wondering. So me as a, you know, as a software developer, we're looking at new technologies. What kind of projects would something like this best apply to? That's the motivation for my question.
And we get that question a lot of the times, but actually, yeah, there are several use cases probably where it is maybe a bit better suited than for others, but there is no real limitation. If you ask me, I cannot say that it's not usable in situation X, Y, or Z. That's not the case at all. As long as you have data, and which application does not have data, as long as you have data, it works fine with it. I will show you later on. In theory, and in practice also, but in theory, you can also work with the terabyte of data. Also, if your memory is not as large as the terabytes in size, of course. So there are what we most of the time say that there are 3 use cases where probably it is the most suited for, but again, it can be used in any case. Remember with the microservices where I said that you need a local cache of the data. And so where that event streaming informs you, hey, this is the new data, etc. Those are, in our opinion, an ideal candidate. Don't put then again a mapping on that, store it, just use the raw data, the objects, the Java objects, then as your cache. And it's also a cache. And so if you suppose that you lose something, but because as I said, there are sometimes a few edge cases and quirks. So if you lose something, then that's not dramatic because it's only a cache. And if you start it up again, you have the data again. Things like those serverless, because yeah, creating connection to the database, that's also the reason why there is a connection pool that takes some time. They can take up to 300 milliseconds or what. So to avoid that, you can just immediately, and that goes faster than that amount of time to create a connection to the database, just immediately read the data and deserialize it and use it. So that's another ideal situation, if you ask me. But again, basically, if you have data, and every application has data, if you have data, you can use this. If you are storing it today to an external system, and most of the time it is a database, but it can be an NoSQL, or it can even your own custom-made serialization thing or whatever, then MicroStream can be used in place of that existing system. I know it's a bit vague in the sense that I cannot say it is usable for X and not usable for Y, because it's not the case. It's you can always use it. The third one, because I said 3 and I only mentioned 2. The third one, what we see as a very, very useful thing, because it is pure Java, you can use it also in Kotlin, Scala, or whatever, but also on Android. And on Android, if you need offline storage, because you're maybe not always connected, or you do not want to store, you do not want to send everything all the time to the server, then the SQLite databases are used for that. But again, there you have a database, so this can be then also a solution instead of using that SQLite database on Android devices, for example.
With the RDBMS option, do they typically store like other columns that help with querying? No,
it's not stored. The system creates automatically 2 or more tables, but yeah, that's just a single field in the table, which is blob. So that is, and you do not know what's in that field. Yeah, it is just because it is binary, and I can already say now it is a custom-made serialization. So it's not the Java serialization. So even if you would try to read it and decode it, well, you need to know how MicroStream does his serialization before you can decode what is there.
okay, thank you.
Anyone else a question?
I mean, I'm a little like confused between, so MicroStream is, instead of using JPA, we can also use MicroStream, right?
Yep.
That's one.
That's one of the ideas, yes.
Okay, okay. And you mentioned caching, like we can basically, so assuming we have a huge, I don't know, like a sorted list or some complex data structure in memory, and we can persist it using MicroStream persistence. So when the JVM comes back up, we can just load it straight into memory and not do like a lot of heavy processing, right?
Right.
Isn't that kind of usage what Hazelcast also provides?
Mm-hmm.
Like I haven't used Hazelcast a lot, but like, is that similar to what Hazelcast would provide or not really?
From a functional point of view, yes. With Hazelcast, yeah, the open source version of Hazelcast, you can indeed cache it, but it's only in memory, so you cannot persist it somewhere. So if your Hazelcast cluster, if every member of the cluster goes down, then you lost your entire cluster. Unless you have Hazelcast Enterprise, where you can also have some custom serialization there, also not Java one, a custom serialization, so that if your cluster goes down for whatever reason, that you did not lose the entire cache. Another caching solution, what is mentioned a lot of times, is EH cache. And it works similar. And in our latest tests that we did now, we need to write everything out and make a nice post of it. But the performance of MicroStream is much better than EH cache.
Okay.
So, but yes, from functional point of view, it is yeah, the same.
Okay, so just because we're talking about caching, so when we are saying we're talking about Hazelcast integrated with Payara, essentially Hazelcast is the implementation that whether we use Jcache or I believe the data grid, it is essentially still Hazelcast under the hood, right?
Yeah, Hazelcast provides implementation of the JCache specification. So yes, you can use the JCache specification annotations, and then it can be backed by Hazelcast. But the same here for MicroStream. We are also providing a JCache implementation with the additional benefit that you then also can persist it automatically that cache value, if you like, of course. It's not required, but
okay. And in that case, if we use MicroStream, then we won't necessarily be dependent on Hazelcast. We can just be dependent on whatever persistence layer we are using, right?
Yes.
Okay.
It's like a bit like JPA. If you are using Eclipse Link or Hibernate, it does not matter. If you're limit yourself to JCache within your application, then you can use Hazelcast as the medium where the data are stored, or MicroStream or EH cache, or there are several.
Okay. Yeah, that clarification was really helpful. Thank you.
Yeah. Okay. So let's dive in a few code examples. If there are other questions, we surely can handle them. Let's do a hello world. What else do you start with than a hello world? Yeah, so first of all, I mentioned already this storage manager. So you need to define that storage manager, and yeah, there are several possible ways of, I mean, with different levels of granularity. I'm going to shut down, delete this one first. But the simplest one is just that you specify two parameters, that you start the storage manager with two parameters. One is the root, that's what we call the root, and that's your object graph. I mentioned already, you have an object graph, and you can only have one object graph, which is managed by MicroStream. Most of the time, it is like that database class that you saw in that example here. It is yeah, a bit stupid, but okay, it works. And for explaining a few things, it is nice. You just have one string in your entire object graph. So this is your database, this string content. We can store there a value, and that's it. But I will see a more elaborate example in a moment. So that object graph, we need to provide it to that start and this allocation. In this example, it is just in the target folder. There will be created a directory where it stores the data. In the beginning, there will be no data because the data root, then there is no string, so it will be empty. You will see that that will be empty. Then we set a certain content. We use store root because this is a simplistic version, but you can see how it works. It stores this change that you have so that it is available later on. And then you can shut down your storage manager. Well, not here because it is in the try with resources block. So it is already closed here at the end of this statement. But yeah, it's nicely that you close those things, but it's not necessary. It's crash safe in the sense that after that this method has run and after that it is executed, yeah, your entire object graph, in this case that single string, is safely stored to disk. So if it crashes then or not, it is nicely closed or not, that does not make any difference. Did I click debug? Not that is a real issue, but it's a bit slower. So let's run that example. Yeah, there is SLF4J with a few log things. So just I did not show the POM file. But first of all, our database, our object graph is null. So our root is there because we did here a new data root, but that string is here null. So that means that we get a null here. That's what is initially there. So there was nothing stored on disks at that location. So it was nothing. And then we updated that string with the hello world and the current date and time so that you can see the thing changing. So the memory content at shutdown was this one. So 43 seconds after that in that minute. Back to my hello world. If I run it again, although I do here a new data root, by using the start, the information from what was available on disk will be again used in my memory, those at that 43 seconds. And yeah, you have still have again the situation where your application stopped, and then yeah, okay, I have updated it. So then at that point it was with 34 minutes, and then when I, of course, I run it again, it is updated. So this in the target directory, there is here a data, and there are channels, more on that in a moment, but here this is the binary data. If I look at that, yeah, that's binary data. You cannot make much sense out of it. You see it's already a bit larger than you expect for that single, for those two classes, but that was also the reason why I said that binary representation would be a bit larger than the database one. This is called a transactions file, but yeah, you do not really have transactions in the sense that you cannot start a transaction, a commit, and roll back a transaction. But transactions here is that every time that I do here that that store, where was it here? That store or that store root, the serialized data of what needs to be serialized, more on that in a moment, will be appended to this file. That's also why that file looks a bit larger than you expect, because we always append things. And each time we append a block of that information, each time we do a store, that information is kept in that transactions file. Of course, if we keep on appending, then this file will grow ridiculously large and it does not contain a lot of information. So also in the background, there is a house cleaning thread running, which cleans out all the old references that are no longer needed, etc. And that transaction file is also used for that, to determine where blocks start and ends and those kind of things. I already mentioned it. This serialization, this conversion to the binary, to some bits and bytes, is not the Java one. Especially because at 7-8 years ago, the Java, the native Java serialization has a few problems. It had a few problems, and it still has a few problems to be used as a data storage solution. The problems it had at that time was that, yeah, you know it, there are several security vulnerabilities associated with that Java serialization. Because when you deserialize a class, a lot of things can happen already in the background. There can be the constructor is called or can be called. There are those read object methods which can be called. And that makes that you can have those gadgets change, as they call it, so that a combination of certain classes that makes that if you present that in the serialized format and use the standard Java deserialization, then you can execute any kind of logic on the server. I've made an example with that at a certain moment where I can just do a listing of my entire disk by starting a deserialization of a very short bit stream. So that for sure was a reason to not use the Java one. So it was a completely written from the ground up a new serialization. The second reason why it was chosen to create a new one was because the Java, the standard Java one, requires that implements serializable. So if it's not serializable, you cannot serialize it, which is probably fine, but that of course that limits the possibility of some classes here in your object graph. The idea was every Java class, if it's in the standard JDK, if it's in MicroStream, is it in whatever framework in library which is already written or will be invented in the future, every Java object needs to be serializable by that MicroStream serialization framework. So that means that we cannot have implement serializable, that we cannot have any kind of annotations or a requirement or an abstract class, etc. So that was the second important reason why an entire new serialization was created. And it needs to be safe. So that means that, for example, there are no constructors called, and even yeah, I cannot do it. Yes, I can do it. There is some nice trick that you can do, for instance, like this one. And you create a standard constructor with select none, but you throw there a runtime exception. And then, of course, I need to bypass it like this. So this is one of the proofs that the default constructor, etc., is not used within Payara Micro. If you do this with other serialization frameworks, then you get at runtime exceptions. Here, purely the data is stored on disk, so not and there is no need to call the constructor for instance the default no parameter constructor. And this class, the type dictionary, because in the file here also, in the file there is also no class names, only numbers, and here there is a match, as you see. This 1,067,000 ID number corresponds to my data root, and that Java string, that string with the name content as a variable. And even I can show you, let's say that we are changing now this from content to value. Select all changes, all these changes. If it's working fine, then my application is still working without doing anything, which is not possible at all, even with the data it had before. It comes to say, well, I found some differences between the things that were serialized and are in your classes for the moment. So, but he created a default, what's called legacy type mapping. So he created an automatic mapping from the old situation to the new situation. Sometimes if the changes are too complex, too big, too you did too much at once, then then the system cannot figure it out for himself, and then you need to create such a legacy type mapping yourself, saying this was the old situation and this is the new, and this is how they are linked. That's standard Hello World. That's a bit about that data that is, as I said, it grows, but there is also a cleanup task that is running. And in general, there are around 15 or 17 systems within MicroStream. That legacy type mapping is one of them. The serializer is another one, etc. So there are a lot of things. The writer, for example, that writes the data to through that abstract file system. But most of the time, this Hello World one was really simplistic. Most of the time, you are using this kind of configuration. Here they create storage manager. You define 3 to 4 things through this. What they call foundation. It's about it's kind of a builder. A builder is the simplistic one. The foundation is a more complex one, because but okay, that's a bit of in the naming. You can discuss about it, but think about a foundation as some kind of builder. So you create that foundation, and then you need to provide those 3 things. One is that path where it's stored, and here you explicitly say that it is the file system, and this is the MicroStream one. It's not the Java one, but it is the implementation of the abstract file system for disk, and that's non-blocking. So that's created non-blocking. You have 2 channels. So you have here in that example, Hello World had only 1 channel. So then there is only 1 thread. If you say storage manager store the changes, then there is 1 thread in the background that handles that request and writes your data. It can be, of course, that you write more data. Sometimes you can write entire lists or etc. So that takes more time, and then it can be useful to have more channels available, more threads working in the background. So this is the configuration of the workers which handle it. It always needs to be a power of 2, a value, so it needs to be 1, 2, 4, 8, 16. The reason for that is that for each object there is a kind of hash code generated with the number of bits that are in that value so that means that based on that bit code there, that hash code, it is assigned to a certain channel. So that's the reason. You can also have a backup system, and then you have a duplication at all the time at your available, and then you can start it. So you have your storage manager. You can start the storage manager. In the beginning, there was no products, so this time the storage is a list of products. Initially, there will be no one and no product there. So I load a few products in there. Here I just use a few products, and then I store the product itself. The list of products, because the idea is that you saw in the Hello World that I use store root, but it's not going to work in most cases except for that Hello World. First of all, storing the entire object graph every time is of course not very efficient. If you have a large object graph and you change one single Java member and storing for that the entire object graph. That's of course, that's not good. Just like creating that large WAR file or executable jar file for only a single file. That's it, a single change in statement. So there is what's called a lazy evaluator. So he starts, and I'm going to show you with this root here. So if I would ask to store this object, this data storage, it says, yeah, okay, fine, I'm going to store it. And it looks at all the members, all the variables that are there. And he sees that, yeah, this list of product, this error list is not changed. So the reference is not changed because, yeah, it is final, but it was the same as the previous time it has stored it. So at that moment, it says, okay, this reference is not changed. I'm not going to look any deeper into the object graph. Which means if I add here in this load per products, if I add those 4 products to that error list, that means that those 4 products are not stored, are not available in my persistence storage on disk. So the rule is that you store, instead of store root, you call store, but you give it a reference of the object, what is changed. What is changed in this case, it's the list, because you added an item. So that means you give it the list to store. Suppose that you have a product somewhere, you have a product and you have retrieved that product based on ID. Let's say that you have something like this. Yeah, it stays red because I do not change the, I do not implement the method, of course. If I then change the name, for instance, of that product, then what do I need to store with the storage manager? Why is it not like auto-completing? So what do I store? The thing what is changed. What is changed? The product, because it received a new name. So I call store of the product. So if you follow this simple rule, store what is changed, then you always have the correct data offline in that file, so that if you start up again, that you have everything that you need. So let's try that out. So the first time I have no product, so I add a few, and the following times I have already products, and that means I just print out and I don't change them. Okay, it's compiling and it's running. So a number of products, there was 0 at shutdown. I have those 4. If I run again, then I have those 4 products and they are printed out. And this time that it's in data 2, you see there are 2 channels. The system is responsible for finding and everything out. So don't worry, that works fine. It's this basic functionality of that persistence framework is there already for 7 years. So that is error-free at this moment. I mentioned a bit earlier that there, what if you have terabytes of data? How can, is it possible to use it with MicroStream? Because yeah, probably your runtime does not have terabytes of data available. And that is possible through what's called a lazy reference. It was made the decision to make that the developer explicitly indicates what is loaded all the time. Until now, these products, for instance, if I start up, the X amount of products from disk are read into memory. Okay, that's not a problem because it is it is probably small, but what if it is large? Then, well, we can say that they are lazy loaded. We explicitly say that this list of strings is lazy loaded. So it's not available at startup, only when we access that list. If we explicitly look into that list, then it will be loaded from disk and will be available. And after you have used them, you can say, okay, clear me now that content again, meaning that it's not deleted. Well, it is deleted from memory, but it is still available on disk. It's like a bit like that, like the Schrödinger cat. If you know that story, if the cat is alive or dead in the box, you have to look into it to know the result. So you have to look into the lazy reference here to get the actual items here. And before you look into the lazy reference, the JVM does not know what is there. I tried again. I should have known better, but I tried again to demonstrate that if you remove those things from memory and you ask for a garbage collection in Java, that the memory is freed and that you can see that it is actually removed, but still available if you start up again. But as I knew, but okay, I tried it anyway to see if it changed or not. But yeah, this is a hint to Java, please perform a garbage collection. But he says, nah, I don't see a point of doing it now because there is enough memory. So it just ignores it. So, but I can still explain what's happening with that garbage collection and that lazy and the amount of heap that is still available at the different points. Let me explain it and then you will understand what I mean. So I create here at some point 50,000 strings there. That lazy was a list of strings. I create 50,000 strings, rather long strings. So at the moment that I start creating the at those 50,000 strings, I have 243 megabytes of available heap. I create 50,000 and then I have 146 megabyte free heap. So I create for about 100 megabytes in size of strings, which is nice. You also saw that it took some time to generate. You will see later on, reading them is actually much faster than generating that entire list. And for some reason, if I try to clear it, I have here do system garbage collection clear. So I clear them everything out. For some reason, it says afterwards that I only have 15 megabytes. So I have lost somewhere 100, and I have no idea why. But okay. That's one thing. Most important, 50,000 strings of size around 100 megabytes. So they are now in that lazy storage. You can, it's here in that lazy data. It's just in one channel. Then maybe that's indeed an idea already to have a look at the size, how much that takes on disk. If I run it for the second time, then it's I start with before my microstream started, I had 250 megabytes because that's my default. After it started, I lost a few. Then I can ask here, where is it? Here on my lazy, is that lazy data loaded? I can query the status. It's not loaded, but it does not trigger a load of the data itself. So I can ask, is there already something, yes or no? But if it's not there, it is still on disk, not loaded. If I then peek for the size. As I said, I do a get on that lazy reference, and this is a size then from the error list. I get that it is 50,000, so it gives me the correct value. But if you see the difference before and after I do that size, you see that bit that size command, he also loaded the data, and because I lost around 100 megabyte at the same amount that I lost when I created them. Now that you know that the data is loaded between this moment and this moment, I'm going to run it again. It's the same 100 megabyte, which is loaded at that point. It's not instant, but it is like a few 100 milliseconds. So in a few 100 milliseconds, it is able to load 100 megabyte of data. So that is the basic things around MicroStream. The hello world, to tell about the concepts, all the configuration options, and then that lazy. There is a lot more, but that are the basic things. Any questions based on what I showed you? Okay, nice. Back to this one. So as I mentioned, there are two slightly different flavors. One is for Android, one is for the standard JVM, but it is Java. So there are examples on somewhere. If you follow on the website, then you find examples also for Kotlin, Scala, etc. That makes use of it, because yeah, it's just Java, and those languages can make use of those Java classes. So the persistence itself then delegates its work to the serialization framework, the serialization framework which converts from Java objects to that binary representation. Then there is also that system garbage collector and that housekeeping, which is running all the time in the same threads as the writers that use the file system abstracts layer, which potentially goes through a database connector or for the backup. So the backup is just a copy of that binary data, which is written to one source, which is then written also to another target. That backup, the primary for your MicroStream can be a file, and the backup can be a database. The backup, the primary can be the database, the backup can be file, whatever, because it is at the end here of the chain, the binary values are propagated to that file system, and there is just written out twice or only once if you don't ask for a backup. The persistence is responsible for storing and reading, but it gets then the help of that legacy type mapping to see if there are any changes, and then tries to map them for you. As I said, if there are moderate, those changes like I did, I just renamed a variable, then is perfectly capable of sorting it out himself. For all existing data, he used that legacy mapping. Of course, if you then save again, that then in the new format, then that legacy type mapping is not needed over time anymore, because probably all data is written in the new format and with the new names at some point. Some people find MicroStream in that sense also a bit scary. That was the word what they were looking for, because your data is there, in that binary format, but you cannot see it anymore. It is there, but you cannot get your hands on it. It's okay, yeah, in a database, you can do an SQL query outside of your Java program, and you see your data. The same for a lot of other systems. But here, it is possible, for instance, to export the data to some formats. You can, for instance, export it to a comma-separated value file, but then a file for each type of class that there is. So it's not really that one blob, that one bunch of data that you see as like you do in a database. For that reason, there is already available the REST interface. So there is a REST interface built on top of this one. You need to add a additional dependency, which reminds me that I need to show you the dependencies. You can add another additional dependencies, which then is capable of exposing your object graph. So it reads the object graph from data, and then it can expose that through REST endpoints. And there is what's called a storage browser. So that's a Vadin application that uses that REST interface to visualize your data, which is available in that binary format. And secondly, we are now working on other options to expose the data more. We are thinking about why not create a JDBC driver for it, that where you, of course, needs to, if you say select from something that you say, oh, if I get a request select from, then I'm returning a certain set of objects which are in memory, etc. So those kind of things to make it better interconnected with other systems, to give again access to the data in many formats. That's things that we are working on for the moment. I'll show it then immediately so that I do not forget. What do you need as dependency? You only need one dependency, which is the storage embedded one, which has a few transitive ones, but there are all microstream ones. So there is no external extra dependency introduced in your project when you add the microstream dependency, only the SLF4J. You have seen, for instance, here all those log information if the storage systems is stopped and the type handlers, for example, are initialized, etc. That can help sometimes for debugging purposes. This is only the info. You can set it also to debug. That's added now in version 7, and that means that you have something as like SLF4J simple to get this output list. And that's the dependency. So then there is another dependency, as I mentioned, for that REST browser, etc. You can have a look at the examples that we have already that is there, so that you can add the REST browser to expose your data. I'm not saying that it is a good idea to expose your data with REST in production, but yeah, you can always have there a peek at what is in the storage if you do not feel comfortable. And in the beginning, it can be a bit because it is a completely other way of working. It was also for me a bit of an adaptation period a few months ago from how do you work with it, with this. Did I not lose some data? And sometimes I did lose data because I did not use the correct store method, etc. Same if you forget to insert or update with the database, yeah, then it's also not there. Any questions? Because I have still another demo, a few other demos, but these are the most important subsystems of MicroStream. and how they work together and to realize what you have seen already. Tons of questions, but it's a good getting started. Maybe we don't have time for a ton of questions, but what's your most burning question?
I'm currently totally flushed from what you just showed us.
Okay.
Well, you already answered some of the questions regarding how to get a view inside the binary data, regarding the REST interface and the storage browser example. Yeah, but I'm still confused. Sorry.
Yeah, it is.
I can't even sort out my questions there.
Yeah, it can be confusing. It's a completely new way of thinking, and that probably takes some time for a lot of people to really get to the bottom of what is MicroStream doing now and how does it work.
But maybe one question. I'm still thinking in querying data like with SQL statements or like JPA does. How do I get the data from the database? For example, how to get the one product, not all products, but one of them, for example. You know what I mean? Understand?
Yeah. Understand. I already more or less wrote it down a moment ago, but no problem at all. You see, how do I get the product with ID 2? So product is gets products by ID 2. And then I do a system out print of that product. And this will be strange maybe, but I just say data storage. No, I don't have data storage because I don't have my root, of course. So I get from my root, I get all the products, I stream them, I find, is it fine? Yeah, it is fine. Why is it not? It find the product where the product, am I now so, is it now so late that wait, get products is a list. So I can stream a list, no? Yeah, that's a product. So on the list I can do find, no? Help.
I'm not really sure about the syntax, but I get the point, I think.
If it's not going to compile, then of course half of the fun is gone. But filter. It is late for me. Sorry, guys. It is really late for me. That's how you query your database.
And is it, I think not, but is it possible to do this lazy as well?
What do you mean? So that you do not load all the data?
Yeah.
Yeah, that's indeed one point. You need to carefully consider how you construct your root object here.
Yeah.
Because with that lazy, yeah, I have indeed one lazy object, but it is containing the 50,000 strings. I cannot say load me only string 1 to 10,000. It's loading the entire lazy one. So suppose that you have an order. Again, I'm going to write here some pseudocode and some things that that hopefully clarify what I mean, that you carefully need to design your object graph. So I have an order, a class called order for a customer. So if I want to later on access the orders for a certain customer and only those orders, then I have probably something like this, like a string which is the customer ID and a list of a lazy list of orders. 1, 2, 3. So whenever I ask then, so that's orders by customer. So then what I can do is orders by customers, get customer ID dot get. This get is for the lazy. And then that returns me a list of orders, but only for that customer. And if I now for that same order, and that's what I mean that you need carefully to design it, I want to have a summary of a monthly summary for all the orders. An order has an order date, so I have, let's call it a class month year or something, which combines the identification of the month and the year. And I have again a list of orders. But then that's the orders by month. So if I then later on only want to have all the orders for a certain month, so let's say get the orders for last month, so let's say May 22, yeah, you know what I mean by this, and I do it again a get, then I only have those orders from that month, and that can be any kind of order for that can be for customer 1, 1 order for customer 1, 2 orders for customer 15, etc. Because yeah, you really need to think about object graphs and how you and references between objects. If you have, when you have created this lazy list for a certain month with certain orders, but that order was also part for here in this map, well, then I have one object in my memory which is used in 2 lists, one's in this one and one's in the other one. When I then lazy load one of the original lists, then I get that original order, but based on the customer. Or if I load that list based on a month, then I get that order, that same order, which can be again removed from my memory because I did not need it anymore, but loaded now in the context of a certain month and year combination. Yes, it is confusing, and yes, you need to think in a completely, not a completely, but in a different way.
Okay, but in your last example, if I lazy load the orders by customer and change any information within the object, and later on I load the orders by the month, it gets the very same object, which is potentially updated.
Correct. So even
cute.
Yeah, for example, I load all the orders for customer 1, and I change one of the orders for customer 1. Even when it is still in memory, that change of customer one, that change of order, the order for customer one. If I then load all the orders for a certain month, which also includes the order for that customer one when that changed, then that order is not updated because he sees that it is already loaded and does not load again the old version from the disk, but keeps the new version which is already in memory.
Nice.
It is working perfectly, but you see this the simple idea of put the Java objects as primary thing in my memory. Yeah, that if you think more and more about it, there are a lot of things and they are all covered.
Hey, Rudy, a follow-up question there regarding JPA and MicroStream. If you could encapsulate in just a couple of points, what benefits MicroStream gives you that you cannot get with JPA?
No mapping, no external system. Well, okay, that's between brackets. What I mean is no primary one. As I said, the for the database is your primary source for your data, which is external, which means that every time that you need to access it, you need to load it. Here with MicroStream, it is not the external system, which is the primary, which means that you need to load it all the time. If it's in memory, it is there. You don't need to load it. And then, of course, is the query performance speed. We have queries, and that are not that okay. There are more complex queries, but it was like a query with 3 tables, a few where clauses, etc. JPA, the ratio of the time that it took JPA against MicroStream was a ratio of 1,400 to 1. So JPA took more than 1,000 times longer to execute than MicroStream.
Yeah, that's significant.
It's not always like that. It can go from 10, 15, but yeah, of course, it all depends on your data, your queries, etc. I think it's even on as an animation, not live. I'm still trying to find out some of the there is somewhere on the website where you can see, oh, this query that took some X amount of milliseconds, this took only that amount with MicroStream, but yeah, if you need to find those things, then of course you cannot find them immediately. That's for sure.
That's fine. Another question I had is, how does it work with, in this case, you're loading all the data up in memory. What happens when some other external source changes the data?
That's one of the things that you never should do. The storage manager, where is my storage manager? This storage manager should be the only one who accesses the data concurrently, in the sense that I should not have 2 storage managers who points to the same data directory here.
I'm thinking of the use case where some other system is putting data into a data source, and then you have an application that's reading the data from that data source. And so that data is continuing to get pushed in or modified or whatever. Is that?
Well, yeah, if it's strictly, as you mentioned, one that writes and the other is read, then probably that will work.
Okay.
But the restriction is that no two different storage managers, and that also includes if they are in different JVMs, should write to the same data directory. Because if you do a store like, where is it here? We do a store like this, then it stores some Java objects from your JVM into this file. But if you then concurrently write from another JVM or another object graph with another storage manager to the same file here, that will go horribly wrong. Because as I mentioned, these transactions define when there is a beginning and an end of a block. And now those blocks will be mixed up together, etc. So it will be completely destroyed, your data storage. So yes, that's for the moment one of the restrictions that you have, that, and I will already answer that question. Then what if I have 2 times that service A that we had before? How can then save that to the same data here? Well, by default, it is not possible with the things that I showed here. There is a dirty workaround with what's called the communication. There is something here. You can do communication. Where is it? Storage. Again, I'm not finding it, but I should find. Which means that one of the 2 instances of service A will be promoted to a master, and he's the one who writes and reads to the storage, and the other one gets his data through a not a REST interface, but it's communicated binary from one process to another. You have to write that mostly yourself, that communication thing. Sadly, that I do not find it immediately. The other solution is that you have to wait until after the summer, because we are working on what's called the microstream clustering, the cluster product, where you have multiple instances available, and all those things are handled for you out of the box. So that's one thing that that is in progress, and that is really needed to make use of that in a lot of situations, because otherwise, as I said, you can only access only one storage manager can access that. Your situation that you mentioned, that there is one process that reads and writes and another process that only reads, that's an interesting one, and maybe I should try it out, and it might work, but I am not 100% sure.
Okay, thank you, appreciate it.
Because they always say to me, only one, you cannot have multiple that look at the same, so look at the same data. So, but knowing what I know about internal things, read only, yeah, probably, but that's a good thing. I'm going to write it down. Any other questions? You know, I love these kind of discussions, because you can read blogs, I can create videos, and you can look at those videos, and yes, they can be useful, but here I can try to help you for your specific use case, of course. There are some occasions that you want to serialize a few objects outside of the entire storage here to data or lazy data, it's to a directory. So with this dependency, that persistence binary, you have a few classes which are made available to access the serialization framework on its own. So not the entire thing about legacy data mapping, not about storing the writing, it just converting it from Java to binary and from binary to Java. It might be useful, might not be useful. That depends on this situation. And to show case, another thing here is that it can handle circular references, which not every serialization framework can handle properly. So let's have a look here. So we have 4 employees, and each employee has a boss or has a manager. So for employee 3, the manager is employee 2, and 4 and 2 have the boss as manager. So if you print it out, so if you look more deeply, I'm not going into detail because it's already, and it's not that important, but you know what circular references are. This is a typical example of a circular reference. You can go in a circle definitely if you want between the boss and the employees, and you can go around and around because they are all linked together. But if you add that with that serialization, again, foundation, think about a builder. I can just ask for the bytes serialization that serialized to bytes. You also have another one, and then you get a byte array back for that little object graph at those 4 classes, and then I can deserialize it back, and then I have something which is reconstructed. I can print it to see if it's the same. And to prove that it is not actually the same object, I print out if the references are the same. The content will be the same, and the equals will say, the equals method will say that they are the same, but the reference is different. So I really made a copy of it. That's the point. So this is the original one. It says direct reports X and Y and etc. And so that's the original data. And if you have time, you can have a look, and then you see that this exactly is the same. And for each object I printed out here, that's employee. Where I print out, where is it here? I print what's called from Java, the identity hash code. That's something from system. That's as close as you can go to a pointer in the native system within Java without leaving Java. So each unique object has a unique identity hash code. So, and then you see that it is clearly that it is a different object. And if you ask a plain Java with are those references the same, then it says nope, they are different. So it is actually a copy that I made from that circular structure. I'm not going in detail. There is also integrations. There are integrations available. We have a Spring Boot integration. We have specific integrations between in Helidon MP. We have one in Micronaut, and we have an also generic, but generic does not mean that it is bad per se, but we have a generic CDI integration. What is the idea? It was a first tryout. We are now working on an improved version of this. But the idea is that to work a bit more like the Jakarta EE way, and more familiar with some ways of working if you're working with databases, because here you explicitly need to say, where is it, my basic here, you know, in my full control, yes, my full control, I explicitly need to say that it needs to store a certain reference, which is something that we are not used to do. So can we work a bit more like JPA, for instance? You do a commit, and at the end, everything that is changed is written in the storage. So for that, you need that microstream integration CDI artifact that brings in that persistence, all the persistence manager and all the other dependencies that brings it in. So no need to do that specifically. And so the idea is that, and you can give it all kinds of names, but you have that root object. I remember you need that first object where, and so that the system knows where to start with when it needs to serialize. That one is here indicated with at storage. So that's a new annotation from MicroStream. And it basically tells the system, this is the root. Because the root needs to be handed over to that storage manager. And the storage manager is created just by using some configuration properties. So we are not doing new storage manager or that embedded storage foundation and all that long way. That's all hidden behind the scenes. We just give it a few configuration parameters. So that needs to know where to find the root. So that's the reason why we annotate a certain class as here as root with at storage, and that immediately becomes also then a CDI bean. You can open it here, but that was now not. I thought it would bring me to the place where it is injected. And it is here indeed. So I can just use inject of that class, that inventory with that at storage annotation, because that is that became a CDI bean with scope, application scoped. And here we save a product. So it's again a REST and a small REST endpoint. We add a product and we add something to that inventory, a set of products, and not a list this time, but it also works, and it adds that product. And the only thing that we need to say is store, and that's a binding. You see an interceptor binding. So this tell the CDI interceptor then looks what is changed, and in most cases it finds the differences, but not in all cases. So, as I said, it is a first. It was a first ID, and it worked fine in a few cases, but we found already cases where it does not work. So we are working on improvements. Why are we doing this? Well, we want to, just as with Jakarta EE, we want to keep out the infrastructure out of your code. So we want to keep as much as the things out of it, so that you don't need to, I don't know, it is possible, but it's probably not very clear where I should then in a web app application for Payara Micro, where I should write this, where I start the storage manager, etc. So hint, if you want to do it, make a CDI producer. But yeah, you see, then that's a bit more complicated. So let's hide that away. Just add storage, add store, and I know it's not a good place, but it was convenient. A few configuration parameters like, oh, my data will be stored again in the target directory, and I have 2 channels. Just by setting a few configuration parameters, it knows enough. This only works also for the moment with the file system, not with a database system, because this only considers creating a file, a storage manager for file. So that's A bit about MicroStream. I can say a lot more. You probably have a lot of questions, but as some of you already said, it's probably first time to play with it. And then afterwards, if you have questions, you can always reach us. We have a discussion page. We have on GitHub. We have, if you have questions or whatever, you can also ask them as GitHub issues. You can reach us on Twitter. Then you end up with me, and then I can certainly answer your questions. But if you have questions now, then we can do it quickly before our break. There is also, but it's in September, a 2 days training on MicroStream, it exclusively, so purely on MicroStream. There is a MicroStream fundamentals. No, it's a 1 day on September 27. That's European time zone, and there is October 4, where it is the American time zone. So probably October 4 is more suited for most of you. You can also wait until November if you like. If there are no questions, then I'll propose that we have again a 10 minutes break. And then we finish off this workshop with some Docker and integration testing using test containers.
Sounds good.
Nice. Then see you in 10 minutes. Last bits and pieces, and of course, we cannot talk in a workshop around cloud native without Docker, of course. Containers was one of those 4 blocks that we mentioned that most people find important if you define cloud native. So as part of that integration testing, the previous time that I gave this workshop, then there was a question, yeah, okay, but integration testing is working with Docker containers, etc. So maybe a quick intro on those containers. We already mentioned and earlier on that you have those layers with that fat and hollow jar, and that it is important for those layers. But how do you actually create those? Are there plugins, tools that are important maybe to mention? So this is available in that extra directory on GitHub. It is a simple MicroProfile web application just with a hello world. It's not the idea to tell you something about the applications or whatever. But once that you have that application, how you can run that within a container. And actually there are 2 ways to do that. You can create an entire, well, not an entire, but you can create a new image based on the official Payara Docker image for Payara Micro. Or you can just use that image and add somehow actually with a volume, you can map your WAR file into that image so that you do not need to create a new one. So let's have a look at that, because I always find it important that you understand how to use the tool, framework, whatever itself properly, that before you are going to try to use some plugins within Maven or so, because if you don't understand how it works in the pure way, through command line, through whatever, then you will probably have more difficulties to understand how a certain plugin works or make use of a certain plugin. So yeah, you package the project. Let's, for certainty, let's do Maven clean package. It generates the WAR file. So I have here my WAR file, very small, just those two classes. And one of the ways that I can run the Docker this application in that WAR image is here by using that volume mapping. This is a bit depending on the operating system, but it works also on Linux and Windows, but with a slightly different change how you write it at what is the current directory, for instance, because I'm going to run it in the current directory. Of course, I can supply an absolute path, and then it is no problem, but I'm mapping that target directory to a certain directory within the container. And that is the directory where by default the applications are expected if you're creating your custom image. So I can then say, well, start up the image for Payara Micro, that version, that latest version. Here that suffix is then for JDK 11. If I remove them, then I have JDK 8. And I deploy then that demo WAR file, the demo WAR file, which was in the target, but since it is mapped to there, I can deploy it in the location using the names internal within the image. If I run it here, I can, and I say map port 8080 from the container to my host machine, so that I can access the endpoint, of course. You see that Payara Micro starts up just as it would starting up on the command line. That's not that much difference. You probably see that it is a bit slower. That's not because of this Docker or whatever, or that the Docker image. It's just that I assigned only a few CPU and a little bit of memory of my machine to that Docker, to the Docker environment, so that I'm 100% sure that if I run a few Docker images, that those don't take over my machine, and that I cannot do anything else anymore. Because sometimes you can have that issue that, yeah, it's easy with Docker, but you run your database and you run this and you run that, and you are running so much that actually your system stops more or less because, yeah, you don't have enough power, you don't have enough CPU. So that's the reason why it is slow, because I only assigned a few CPUs to it. But in the meantime, it started, it's internally had some name, but that's not really that important because I did that mapping. So if I call then curl localhost 8080, and I should have looked better, it is demo data hello. Then I get my hello world back as expected, because that's what this a hello controller does. So this shows you that you do not need to create your own custom image. And again, if we can avoid creating a custom image, that means that we don't have an extra layer. Again, that whole discussion about layers comes up then, and then you can avoid that with a volume here. It's possible to use that in most cases, but of course not all cases, because yeah, your Docker images is most of the time a bit more complex than just running your WAR file. Remember your adlibs for your JDBC driver or your post-boot command file. There are also, I think, always or most of the time these hacks. It's not really hack, but the ways with volume mapping and some additional parameters, etc. But sometimes it is just easier to. I'm going to create a new image. So I'm starting from that base image, again, the same Payara Micro image. And then I copy that demo WAR file from that target. I copied that to that default location, and that's the only thing that I need to do. So as I said, it's good to understand it, how it works, and then that means that you need to build that that image. Payara Micro, I used it already before, so it is that cached version, as we also discussed. I'm transferring my WAR file, which is easy and fast, and you see it went building in 0.3 seconds. Running is then running your image, not the Payara Micro anymore, but your custom image. And the best practice is that you give the name, but also a tag, which is unique in the sense that it should not be kept blank, because then you have the latest, and then every time you create a new version, you are going to use that version. Now you have control in naming it version 0.1, because it is very premature with just a Docker hello. Again, functional wise, it is identical. It starts up, and my hello world endpoint is available from the command line. So that are the two main ways of creating a container for your application with Payara Micro. So here you have the full-blown possibilities of a Docker file and all the type of commands, and pay attention to how you create your layers. You know, here also layers are created, so they should be created as ideal as possible. Question at that point was also, as I mentioned, is there some tooling so that, okay, I have Maven, but can I have with a Maven clean package, for instance? Can I create immediately that that Docker image, which is most of importance during your CI/CD pipeline? If I mentioned that. Locally, most of the time, it will be only the WAR file itself that you're using, probably not the Docker image, but yeah, it's possible that you also, during development, run your application always within a Docker itself. That's of course possible. Are there tools? Yes, there are Maven plugins. There are also Gradle plugins. The most popular one, and the one which works in our case, is the Maven plugin from Fabric 8. That's Fabric 8 is a Red Hat project with around containers, etc. And there you have the possibility, you can create your image in two ways. And one of them is that you create your image with what's called the custom DSL, domain specific language. So they have a set of XML tags that exactly does the same than what we have seen in the first example. So we say, we give it the name. Now I use training 2 and not training to core. I gave the tag, that version number, I specify the from, and then how you need to copy it. And yeah, you need to look at a few examples and a few documentation files, because otherwise you have no idea how he's able to copy that demo WAR file to that image. I'm not a fan of this kind of things because, okay, you have your Docker build, your Docker file to build it. That has already a certain syntax that you need to learn and need to use and blah, 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 etc. And then on top of that, you also need to learn the way to do it here within that plugin. Yeah. Learning one thing is enough. Learning two things to do to have a certain outcome, that's most of the time for me too much, but everyone is free to do so, of course. You will see how this works in a moment. I have there a comment to make. So an alternative way is actually also using Dockerfile, which is, if you look at the documentation here for this plugin and the following one that I will show is saying, yeah, you can do it, but actually the main reason we have created this plugin is that you can do it by this domain specific language. This is kind of fallback, but I find it much more interesting, where I create again another image, and I just specify the location of the Docker file, and then by default is going to look at in the source main Docker. You have source main test, you have source main Docker, and then you have more or less what you know, that you know. Only this one that took me quite some time to find out, that your data is not in target. Well, it is in target, but it is in a specific subfolder that he takes as the root, and it's called Maven. And that's because here the assembly, the name of the assembly is called Maven by default. But if you name it something different, okay, then you also need to change it in the Docker file. Yeah, this is possible to use, but again, this ties a bit to Maven. You see, you have Maven here, and then the command. So again, not a real fan of it. I always put verbose through in the beginning so that you see what it is doing. I've not done it here, but yeah, you can also link it automatically to the package phase, so that if you do Maven clean package, it executes immediately this Docker Maven plugin. Because when I now just do Maven clean package, it just builds my WAR file and not the Docker image. So I need to do Maven Docker builds, and then it builds my through that Docker Fabric 8 plugin. That plugin, it builds the thing. So it has created training. Latest tag with 0. Yeah, okay. First creates the latest and then 0, 1. Okay, that's I didn't know even. What I always look at with that verbose, and I'm now going to show you a very handy tool. Maybe some of you know it. With that verbose tool, you see what he's doing. Okay, step 1 from okay, that's nice, and then copy target to that. Is he copying the entire target directory? What is he doing? Then you have a very handy tool about it. So you take that image name, and the tool is called dive. I'll show you where you can find it. I will put the link into in the chat. Dive is some guy who has way too much time in his at hand, because he created a custom viewer of the entire Docker layer system, and that allows you to do a few things. For instance, at the top, it starts from the initial root image where Payara Micro starts from, and then Payara Micro does a few things. Okay, there are not the actual names, but the hash codes, which is, yeah, okay. But here on the right, you can see then at this layer, right? So this is the final image. Then you can see what is in that that image. So there you can see, and in green it is where it what it added in that layer. He added just that demo.war file in the ops Payara deployments directory. So okay, my plugin works nicely. I did the configuration properly. That copy target there does what it needs to do. It just copied that demo war file here at the correct place. If I then look, if I then go back, I need to no, and how can I go back now? Sometimes it's a bit quirky. As I said, he has way too much time, but it isn't already a nice thing. So if you, okay, I cannot show it to you, but you can go also back to the previous layer, and then you see that Payara Micro copied this one in a separate layer and the entry point to start up the entire thing, etc. So this dive tool is very handy to look at it, because it also gives you here a efficiency score. What is that? So for instance, if you in a lower level create some files which you delete in later layers, well, that file is still there in those lower layers. That means that your image is larger than actually ideally is the case, because yeah, you have deleted a few things which are not there in the final container if you run it, but in the different layers that makes up the image, it is still there. An efficiency of 99% is of course very, very good. So then you don't lose, you don't waste time and spaces. Yes, quit. GitHub, dive, Docker here. You have installers for Windows, Linux, Macs, so I guess everyone will find a version that he can use. I find it very handy, that dive tool. This plugin is the one that I was using most of the time if I needed to use it. There is also the Spotify one. Spotify has open source their own tooling that they are using internally, and you have also the Spotify one, but I think that one is already abandoned a bit longer. This Fabric 8 is still in development, but actually it is now a bit evolved in this new one, which is JCube, is also in the Eclipse Foundation. But sadly enough, they are very opinionated in the sense that it creates not only Docker images, but also Kubernetes resources for your services, for your deployments, etc. But yeah, it works for those default generators that I have foreseen. For instance, it works for Quarkus. It also works for Spring Boot. But for Payara Micro, I cannot get it to work. I can create an image for Payara Micro that works in those both ways, the same thing. But then if I try to create these resources, I cannot do it in the same configuration set than with those images. And I have three issues here that I have already found. One is that you cannot combine. I have not found yet how can I specify the actual image name for that Kubernetes deployment, for example. And it outputs all that YAML in target classes meta-inf. So that means it becomes, if you are not carefully, it becomes part of your WAR file. So I find that a bit annoying. Most annoying, it does not work after 1 day of trying it out. So this Docker Maven plugin, I saw that there was a new version lately also. So yeah, this one, if you really want to use it, then I can say that you can have a look at it. Question about Docker's images. containers, tools to create those things. Then let's use those containers for our integration testing. And before, let's say 3 to 4 years ago, it could be quite challenging to do that entire integration testing. It is still challenging, I guess, the entire testing, but okay. Integration testing is certainly a challenge. You have unit testing, you are testing a single method. You can, for instance, also use mocks. Mockito is very popular to mock a few dependencies with that inversion of control. Instead of inject, you have in the class inject, but you can then define mock and inject mock, etc. So you have to look at some examples if you do not know. Then actually you can inject all the things, either actual working code or mocks and spies, as they call it, into your CDI bean, and then you can test individual methods rather well from all those beans. Always take care that if you provide some functionality through mocks and you call some methods with parameters in your unit test, that they make sense. Because what sometimes happens, that developers are just trying to get a green build and trying to get the entire code coverage above 80% or even above 90%. But what they are actually testing is not the business logic, but they only write tests focusing, oh, I just need to have all the lines green and all the test screens, whatever that takes. Even providing results through mocks, which makes no sense and things like that. So testing is not about some metric, some KPI that you need to achieve, and yeah, that's sometimes an issue of what we tell the developer that he needs to do. But testing is about testing the functionality, that the things that I've written are valid and correct. So be aware on those things, that you test with the proper values and that you are using proper values in mocks. But then, of course, and especially with microservices, you have a distributed system. You have not everything is available, but in a unit test, it would be nice if you could test things in integration. For instance, that with a database, for example, that if your application reads from a database, from tables and fields, that actually you provide a database, that you read the data from that database with some test data, and that you see it is working or no, I made this mistake. And there the struggle starts, because for your test then you need a database, and you cannot have a shared database with all the people that's used by all testing, for example, because for every test probably you need a certain specific begin situation of your data. So if everyone is testing in parallel or whatever, then that will just fail, because the data is not expected. For instance, I expect 10 lines, or I expect 10 lines in an order for product lines, the order lines for 10 products. But at the same time, another test is running that to see if I can update it one to where a line is added. Then there are 11, and that means that, of course, that test fails. With the test containers framework, if you do not know it, then that is easier, because if you need a database, well, as you saw doing it me during the JPA one, you just start one as a Docker container. And that entire thing to start up other containers with additional functionality for your application, or even different, you have 2 or 3 microservices that work together, you can start them up together, and then you can really do live testing with actual systems, okay, in a Docker, but actual systems, not mocked, not crippled in any way, with the actual thing, which is again a good thing. You test the same thing that you that also will be deployed in production. And then it's demo time. Are there many people already familiar with test containers and using it, or is this brand new for everyone? I don't hear anyone. So is it really the first time that you all hear about test containers?
I've heard about them in the past, but honestly, I've not used them up to now.
Okay. Definitely something that you have to look into. Very nice. So I have an example here with that Jakarta EE and that integrations with MicroStream CDI, just because I reused a certain reused a certain example, but you can use it with any combination, of course. A few test dependencies. I'm using JUnit 5. It's also working with JUnit 4, but I guess it's time to move on to that you are using JUnit 5. Assert J, because that allows me to write some nice test assertions to see if the value is expected or not. Adding test container, of course, the basic, all the basic code, and then the integration with JUnit 5. I come to that in a moment. So I have here a certain endpoint that I like to test. So I have, and that's actually from part of the final exercise, where I have a few endpoints and I can do a find by ID and insert and delete, etc. So I like to see if I can test that and if that works or not. So by default, this is how most of the people start, which is not bad, but you will see we can improve that greatly. Yeah, you have the test. It is an integration test. So if you give it the name IT, then it will be executed in that integration testing phase of Maven. So that's after the packaging. And with this annotation at test containers, you activate the extension of JUnit 5 for test containers. And one of the things that extension does is that it looks for variables that are annotated with container, and that means that that is a definition of a container, and that at the beginning of your test class that container is started, and at the end that container is destroyed and is removed again. There are some specific containers, as for instance, you have a Postgres container, a MySQL container, etc. You have a Redis container, a Kafka container. You have quite some containers available. Test containers, container. Let's say, probably if I look for the MySQL one, then I will get them all, you see. So there are a lot of database containers, InfluxDB, even Cassandra, Neo4j, even Oracle XE, Oracle XE because it is free. But you also have, as I said, you have Kafka, you have NGX, you see, you have WebDriver. Don't forget WebDriver, so that you can, for instance, test your web application, etc. So there are a lot of containers by default, but yeah, for our case, we need to create a container on our own, which is based on that Payara Micro. And remember that example where I added the executable file to Payara Micro image. Where is the WAR file? Well, that's it creates a myservice.war file. So I find it in a specific way. So it's not just a file that I point to, but I have something which called in test containers a mountable file. That means that I can add, it's like a volume that is mounted, but now it is an individual file. And I mount that for a certain file name. So that means that I can say afterwards here, deploy me this application. So then actually it is deploying the application that I've created in the target folder. Exposed ports, again, I expose the port 8080 of the Payara Micro in the container. And this is also a good one because, yeah, the container starts, but when do we know when our test can start? Because, yeah, there is some initialization time required before the container is ready to reply to our first request. Then that health point comes very handy, of course, because you remember that health will become up with status 200 when everything is ready. So with test containers, we can define the waiting condition. That can be an HTTP when a certain endpoint says it is 200. That can be something that we can look in the log file. There are by default already quite a lot of conditions that you can wait for. You can write your own, but here for Payara Micro, we wait until that health point says, yep, the application is up and running, and then we can start our test. And our test is then, yeah, that service is a product service. I will show you again more what it is, and then I can starting the test. For instance, in the beginning it is empty. I add another product. I insert a product, and then I see if I request the product, all the products again, that the product that I added is still there. So it's a simple, basic one, but that's the idea. We are not there yet because, okay, this is running locally as client. This is as the test client, and yeah, our application is running within the container. So we need to still make that link. For that, we are going to use MicroProfile REST client again. This is again such an interface where we specify the list of the products with the get all is a get method, and we have here a post for the insert and then delete, and it always produces and consumes applications for all the endpoints. And to convert this interface to a proxy, we need to, for that, an implementation. Payara Micro is one, but yeah, we are not within Payara Micro. We are in a test here. So for that reason, we are adding another MicroProfile REST client implementation, and the one from Apache CXF. Yesterday, there was the question, is it sometimes usable to use some Spring-related things? Actually, this Apache CXF is entirely based on Spring, but it's standalone enough so that you can even include it within. But okay, Payara Micro has also that client, but here in the test is also nice. The Apache CXF itself does not have the converter for JSON. So because we like to work with Java modules, not with JSON. So for that reason, I'm adding here JSON. And then that's automatically picked up by the client. Many different pieces, but they all work nicely together. And for the output, I'm going to use logback. Test containers is using SLF4J, etc. So I'm using the logback here so that I can define a logback test XML file where I dump everything to the console, and that I only for GitHub Docker Java. What is? Yeah, there is one that I need warning. I don't remember why I set this package to warning, but okay, you can check out again, and then standard test containers is info. So we have here our interface. We have now Apache CXF. So that means that in our test, before each test method, there is only one, but okay, that we can create that proxy. Remember, from that interface, we need a proxy. That proxy can call the remote endpoint, but you can also do that programmatically. In the example before, we did it with annotations. So you can do it programmatically. We create a new builder for that REST client. We register JSON for that, so that that we have that support for JSON binding. And then we will call a certain remote endpoint, and that's the base URI. And then we build for this product service a real proxy implement. It's not real because it's a proxy, but a real class that we can use. But what is the URI? Where can we find our application? First of all, localhost. Okay, because I'm running locally, so that's fine. But ports, I only specified here that it needs to expose port 8080. Did it expose to 8080 on my machine? No. Test containers just takes a random value between, I think it's around between 12,000 and 32,000. The reason why is that because you need to run multiple tests in parallel. If it starts up two containers and it exposes both to them to the host port, to the my machine, both to port 8080, then the second container will fail to start because it says, well, port is already in use. So that's why it is using a random port. How do I know which port that random port is? Well, ask the container. The container, here the class that test containers provides for me, he knows which port it is, so we can ask that port there and get a URL, URI. And the last thing that we do in the test is that I like to see the log of Payara Micro in the log of my test. For that reason, I create a what's called an SLF4J consumer in test containers, which outputs to the normal log here from, this is the normal logger from the class. And the container log will be injected by this SLF4J log consumer in the log of the test. A lot of things, but if you see, once you have an example like this, you know all the different parts, then that's very nice to see all those things working together. So I start up the test. It first checks Docker. Well, it first tries to find Docker. If Docker is not there, he installs Docker machine even. So not Docker desktop, but even installs Docker machine. So it takes some time sometimes for all the checks. If that is in a CI/CD pipeline, that does not really matter. You're not sitting as a developer looking, oh, what's he doing? Yeah, at some point you are, but not all the time, of course. You see, he started creating container is starting and is now on the wait strategy. So it is waiting until Payara says withheld okay. And at a certain point, yeah, it switches in totality here, and then you see here with standard out, you see the entire log of Payara Micro. You remember this, and eventually it becomes green because my test executed and everything was okay. And I had a complete integration test with a real running application. I can even use additional containers here. As I mentioned, I can add here a container for MySQL, and then yeah, you can have a look at the example of test containers, how then you connect your application with that MySQL database, etc. That's one thing. You see that all those things are nicely working. Maybe one word here, which I did not mention. I deploy that my application that I'm testing. I'm specifying no cluster so that I'm a bit faster in the startup. I remember then Hazelcast will not start within Payara Micro because yeah, it is just a single instance, so no need to start that. That saves you a few seconds. And yeah, the context root is / but yeah, that is just a way so that I don't need to specify it here, the name that I should use. What do you think? Nice? Some comments, some questions?
Hey, Rudy, just one thing I had. Could you comment on, I mean, it seems like that there's a lot of things that you've figured out and you've found and you've learned and you've put in, and, oh, I need this dependency. Oh, not this one. This one works better than the other. By the time you got everything all set up, I mean, how much time did that take you to get that all figured out?
Yeah, well, to figure it out, well, this I created in an hour. But okay, I know all the things from before what I need to do. I just need to look, oh yeah, I need Apache CXF, find me a project where I used, or I need to find the Maven dependency, etc., etc. So this took me an hour to create the first one. Okay, it's okay, it's not okay. It is what it is.
Yeah, that's, I mean, the unit testing is something that we've been wanting to do for our web apps. Desktop apps, we've done unit testing, no problem, but with the web, it was kind of, I don't know, we weren't sure how to do some of those different things, so we haven't really pursued it.
Yeah, that web part there, here, that web container, that web driver one, that is suited for that. That starts up, so that in that WebDriver container, you can start up, for instance, Chrome or whatever, and you can remotely control Chrome. So saying, click on this element, get me the value of that field and see if, or that label, and see if that is correct, etc., etc. So testing web applications is done through this WebDriver container, and that works rather well. The nice thing what you there also have is there is a screen recording. So for the entire test, it is recording the screen for your Chrome, for instance. So you can see your test in action later on. So if it fails, you can actually replay that video, seeing, oh yeah, I clicked there, that was okay. Oh, there it went wrong because the data was not showing correctly, or it was shown but in another format than my test was expected. So that, yes. Your other question saying how much time does it take to learn all these things? Well, I cannot really say. It grows over years, and I always improve on a previous version that I have. And one of my first versions did not have here this MicroProfile REST client. it was just using the Java net classes, so that just a connection to a generic URL, and I got back some JSON that I needed to parse myself. So yeah.
Yeah, I know it's not a really good question.
Yeah, but
trying to gauge how much time we should set aside for the learning curve part of it, of really understanding and going through and making sure that we can effectively implement some of these things.
I would do it incrementally. If you, okay, you have now this example, it's also on that GitHub. You can study it and start with a few bits and pieces that works for your situation, and then you see, okay, I have now created actually my first test, and that can be probably maybe, I don't know, a week. Let's just say that you need a week to have everything set up from scratch. You need your project, you need all the bits and pieces together with some systems that you do not know or barely know. So the first thing can take a week, and then you see, okay, now I'm copying that one example over and over, and I adapt it, and then you start seeing, oh, but here I see some duplication. Here I see some structure in what I need, and then you can create some extensions on your own, which I will show you in a moment. That I also did. So yeah, that's the only thing that I can say. Just start with it and do it and learn from it on the go.
Yeah. Okay. Thanks. Appreciate it.
Any other question? But at the end, it pays off, believe me. You feel much more relieved that you have at least, you can push a button, and that there are some tests that, yes, I'm not jumping blindly in some black hole hoping that I will land on my both feet, because there is at least some backing up of tests that are working. What I said, for each test case, you copy this over and over again. Yeah, you know, we should not just do always copy paste. We should try to find some structure and to do it better. Another thing which then said, well, yeah, my test failed multiple times, and then that's why I then started adding here the log files. Sometimes I see an exception here in the log file, and then oh yeah, it's there. And then based on the location, for instance, a null pointer exception on a certain line, and then thinking, why is that null there? And then yeah, probably, yeah, okay, I found the issue. But some issues were so difficult that I had no idea why it failed. So I wanted to have a debug session. And that's also possible. So again, that took me some time to find out, but you can actually create an, wait, where is it here? I create my own, as I said, I'm using generic container, but I'm creating my Payara Micro container. And this is actually a slimmed down version from the actual Payara Micro container that I once created. That was like 10 classes with all the helper classes, 10 classes, 500 or 700 statements. So it was a very elaborate system. It took me some weeks, like 3 or 4 weeks to build it, but it had everything what was needed to test Payara Micro and Payara Server in all different kind of scenarios. I copied here a few things because I cannot share everything of those of that work that I did, but I have it, instead of having the generic container that I configure over and over, I create a Payara Micro container. A Payara Micro container where I can say this is that mountable file that it needs to use, or an additional parameter, do I want to have debug, yes or no? I'm using the super here, so I'm passing the base image. I expose again port 8080. I'm copy that WAR file to that location. I'm waiting for that health endpoint. I'm doing the same deploy that you know. But then if I specify debug, I said, well, I add an additional port, an exposed port, and this time I do it fixed, not with a random one, because I export the debug port that I'm using here in this JVM R argument, that port 5005, I'm exposing it, but I'm using on the host also 5005, because otherwise I need to have some way to connect my debugger to that remote port. So you only debug one container at a time. If you have multiple, as we mentioned earlier, then of course you can have multiple here. So with this JVM argument, additionally, I can and give me some more time so that I have just a relaxed time to connect my remote debugger, time of 1 minute before test container says, well, yeah, container didn't start because you see I did suspend here. Suspend is yes. So that means as long as my debugger is not connected, my Java process does not even start. So that 60 seconds there should give me more time then. So then I can use that container here instead of that 5 or 6 lines that I copy over and over again. I just have to, and also this moves then to a utility class, and I can say debug through because it is always the same file, the same web application file. This is the same. Again, there some parts of it you can move to a generic test class, etc., and the test is again the same. And what I can do then is in this, I have here a breakpoint in that save method, etc. I can put breakpoints. So if I now run this one, and I can just run this one because I don't need to debug my test, I need to debug the application, not my test. So I need to run my test. But once it is started up at a sufficient moment, so I just wait a bit, it says waiting strategy. At that moment, I can say my remote debugger here connect to that container. I still now have to wait because the Payara Micro is starting again now in debug, so it has already only one CPU and now it's only also debug, so it is even slower, but okay, why not? Because it stops now at this point where I call at that save method in my test somewhere. I can see what is going on, I can follow it step by step, step over, step into, even change the values. I'm going to change the value to banana other, which then means that my test will fail because it checks on banana and not on other. So I can do that like that, and then I can just continue my test, and it adds there and it stops there, and I can do whatever I want. And then as I expected, the test fails. I need to go back to my, this is my, where is my console output of my test itself? Did he close it? No, it's here, run. And then the output says, yeah, it fails because, yeah, I expected banana, but somehow the system made banana other. Yeah, that was my edit, of course. See, at the last resort, you can just debug your entire system, which is great if you ask me. And whatever you need for Payara server, there was a lot of things that you can add scripting on the fly, that he does it, or ASAP min commands, that all those things. As I said, it was a large project that I did, but yeah, takes some time, but it can be very satisfying that you have all those tools at hand. Questions about testing. So again, you have the link, but my project you can find on GitHub in that repository here at the Payara Micro course with the demos, here the integration testing. There you have all the code, so you can study it and you're free to use it. I don't mind. Questions, as I said, about testing, integration testing, test containers.
So I had a question around like the service methods that typically get injected in via the CDI. So if we are, so my understanding is that there's, I think how I do it right now is, and I'm coming from an Apache TomEE background. So how I do it is at times I just start the server, deploy the app and connect the debugger. That's one way of doing it. And the other is we make the endpoint call and then basically have full tracing or debugging at the log level to step through and see, okay, this is happening, that's how it is failing. And so from what I've understood, test container is also starting Payara Micro image, right? Like it's starting a Docker image behind the scene.
Yes.
Okay, and then it is deploying the war file, and it's essentially asserting all the methods. So if I directly want to test the service methods, like for example, how I do it in JUnit, if I have like a static service method at times, so or the really old dirty way, you know, just add a public static void main and call that method and assert whatever you need to assert, and then you can remove that. So do I need to add independent individual like CDI implementation in Maven, or?
Yeah, I think where you're going, but not sure if it is what I'm thinking. So yeah, so the test containers indeed starts, you see, creating container image. So it creates an image on its own based on that image. And through that volume mapping, the application is available. So then you can see that, yeah, here at the output that Payara Micro boots and that everything is happening. So that is happening in one system. And that's your regular web app, because I took the output of the Maven Clean package. I put that into that image. So it is my entire application, and there I have everything what my application is. My test itself, so the test is running, of course, locally. And there I don't have CDI, I don't have anything. I just have my test method, just as I have a JUnit test method, so a UUnit test method. Right. With that trick here that I create that client, I can call from my test, which is on my local, yeah, everything is on my machine, but from my machine, it's calling within that container, and it can then there test the functionality of my application, but this is just a plain unit test. So I don't have CDI, I don't have a main method, I don't have a thing. What you're thinking maybe sometimes there are some systems, and again, it is because it's so late that the name escaped me now, that you create that so that your tests are running inside your deployed application at runtime. Is that what you're referring to? That you say, can I use CDI? Can I use injection and those?
Right. So basically, assuming you have like a service which is injected into, let's say, your REST endpoint, and you want to assert a method within that service. Okay. So one way is you call the REST endpoint with the correct and incorrect parameters, and then you can figure out if the test is passing or failing. That's one way, right?
Yeah.
What I'm trying to ask is there a way where if we run the test, it is essentially like in TomEE, I know it can start the OpenEJB container, and it does the injection. So you don't have to have the full like container, like the Docker image started in a Docker container and everything else. You can straight away test it like you are calling a static method or something like that, you know.
Okay. Not what I wanted. Yes, it is possible, and no, it's not a good idea.
Oh, okay.
And it's also not a good idea to describe what you do, running it within the OpenEJB container itself. Let me explain why. But first, because I need that name, sorry, I know that I'm using it in a project. So I'm trying to open that project, and then I can see the name, and then I say, yes, that's the name. So sorry for that, guys. It is so long, a long day for me, and I forgot. It's Archillion that I'm looking, that I was looking for. So what you are describing is what Archillion does. They call it write real tests. Well, yeah, well, it is not real at all, because what Archillion does is more or less what you describe. You start, for instance, a container, an EJB container, and you deploy just that one single service to that container, and then you test that service in isolation. And if you need some dependencies, you can mock them again. And also they say no more mocks, but yeah, you have to mock them, because otherwise you have to fill it with the entire application. And then what is the point? What I don't like about those systems, so I don't like Archillion, although I do use it because I need to use it for the TCK test, that test compatibility kit, what I mentioned for MicroProfile. Why I don't like it? Because you are crafting a specific environment for your test. You are not testing your WAR file. You are not testing your integration between different components. You are just testing something that you specifically designed for the test. That can be a single service that you deploy on that OpenEJB container, for instance. So it is much more difficult to make that real world test. Although here they say just real test. No, actually, all those tests are pure fake. You are just assembling a few components, deploy that on something like an OpenEJB container, and then you're testing that. But again, those three components are not your entire application. Those three components can behave differently because they are standalone, and they can behave differently because you have packaged them in a certain way for that test and deployed it on the server and trying it out. That's why I don't like those things. It's like testing, it's not testing the real thing. You see my point?
Yeah, I get what you're saying. Okay, so
that's why I much more prefer something like test containers. Because what you actually do is you just take the WAR file, which should go to production, and you test against that file. No special tricks about a special assembly for this test and few mocks and a few configuration specific things. The WAR file which goes to production. That's what you're testing. And that's what is important that you test. What will be in production? This WAR file.
Right, right. And this container will be in its own memory space, separate
Yes.
from the JVM where the test is running, right?
Yes, it's always client server. Yes, that's something that you need to remember. Your application runs remotely from your test. So this is basically running on my machine, and this because your Docker client can just be pointing to your Azure cloud provider, for instance, and then your test is running with your WAR file is running within the cloud.
Okay, okay, got it. And the, like, for example, in the method below this, where you say service.getAll. So you did this setup, right? And the service is the REST client builder. New builder checks.
Yeah, that's just as convenience. I said that was not in my first version that I created, but yeah, you call that remote endpoint. I want to make it as simple as possible. Okay, I do a get all and I get a list of products. Actually, this is a JAX REST call which returns JSON. So to do all those things behind the scenes, I'm creating a REST client implementation through MicroProfile REST client for that endpoint, so that that instead of this line, I can do it also with the Java.net classes and call and when I get the string back, I can convert that that JSON myself to a list of per product. But yeah, this makes it, of course, much easier if I'm just using this REST client here that I've prepared, because then I have here just a single line, and that makes it also readable. I get from the service, and then naming is, of course, important. From the service, I do the get all. And what is the service? The get all, well, you see it here. That is that get method.
Right, right. Okay, got it, got it. All right. Thank you. This was very helpful.
Yeah, no problem. It is for me, it is Thursday at this moment. But if there are any questions, I'm happy to answer them. But yeah, I'm at the end of what I wanted to show you in these 2 days.
I think it was really helpful for me. I appreciate your time sharing this with us.
Thank you for joining. And yeah, as I said before, I give other training. So yeah, if you have some more need for more in depth or whatever, then feel free to contact me, and we will work something out. So if there are no other questions, then thank you for your attention. Enjoy your evening. I'm going to sleep, but enjoy your evening and enjoy working with cloud native microservices in the next weeks, months, or whenever you are ready for starting to use them.
Hey, Rudy, one last question real quick. How
Yep.
do you intend to share out the recordings?
The recordings will be mailed to you. So we have, of course, all your mail information. And it's probably by mid next week, you will receive a link to the recordings of these 2 days.
Okay, great. Thank you.
Thank you. And
I think
yeah.
I received my links already. for yesterday, right?
Oh, I got a message that they were sent out for the previous session that I did. But yeah, okay, I don't know. It's possible. I'm not in charge for
Okay, just checking.
for sending out those recording links. So I have no idea when, how, and who is. I know who is doing it, but I have no idea when and how they will arrive. They sure will arrive. That's for certain.
Thank you. Have a good night.
Yeah. Thank you and bye.
Thank you, Rudy. Appreciate your time. Thank you.
Thank you.
Yep.